Langchain Azure Dynamic Sessions Tool Summary. None. This tool empowers developers to construct and manage applications that leverage the capabilities of the Azure OpenAI service using langchain. Inputs. Information about your Azure OpenAI resources, such as the resource group, location, and deployment name. Details regarding the configuration of langchain, such as the model to be used, the prompt template, and the desired output format. Outputs. Credentials for establishing a connection to your Azure OpenAI service. This typically involves an endpoint URL and an application programming interface API key. The langchain library configured to seamlessly interact with your Azure OpenAI service. This integration allows you to send prompts to your chosen OpenAI model and receive responses from it. Steps. Establish a connection between your application and your Azure OpenAI service using the provided credentials. Integrate langchain with your Azure OpenAI service by specifying the necessary configurations. This involves setting up prompt templates, choosing an OpenAI model, and defining the desired output format. Prerequisites. An active Azure subscription, granting you access to Azure services, including the Azure OpenAI service. The Azure OpenAI service, a platform allowing you to interact with OpenAI models, such as GPT-3, through Azure. The Azure OpenAI service needs to be deployed within your Azure subscription, providing an environment for model usage. Langchain, a Python library that simplifies interaction with large language models LLMs like those provided by Azure OpenAI service. Fine-tune parameters. Detailed information about your Azure OpenAI service deployment, encompassing elements such as the resource group, location, name, and model being used. Specifications for langchain's configuration, including the model to be utilized, the prompt template, the output format, and any desired custom settings. Challenges and fixes. Authentication issues arise when your application fails to successfully authenticate with your Azure OpenAI service. Verify that your Azure credentials, including the subscription ID and application programming interface API key, are correct and have the necessary permissions to access your Azure OpenAI resources. Deployment issues occur when the configuration of your Azure OpenAI service deployment does not align with the requirements of langchain or your application. Ensure that the details of your Azure OpenAI service deployment, such as the resource group, location, name, and model, are accurate and match the information used in your langchain configurations. Configuration errors result from mismatches between the configurations of langchain and your Azure OpenAI service. Carefully review the settings within langchain, including the selected OpenAI model, the prompt template, the output format, and any custom configurations. Similarly, examine the settings of your Azure OpenAI service to ensure they are consistent with your langchain configurations. Langchain Chroma Vector Stores Cosine Similarity Summary. A description of the cosine similarity calculation process employed in the context of Chroma Vector stores, which are used for efficient storage and retrieval of embeddings, particularly in natural language processing and information retrieval applications. Inputs. An embedding represents a numerical representation of a piece of text, often a sentence or a document. In the context of Chroma Vector stores, embeddings are used to capture the semantic meaning of text. Another embedding, similar to the first one, outputs a score ranging from 0 to 1 that quantifies the similarity between two embeddings. A score of 1 indicates perfect similarity, while a score of 0 indicates no similarity. Steps. The dot product is a mathematical operation that measures the similarity between two vectors. The higher the dot product, the more similar the vectors are. The magnitudes of the two embeddings are calculated by taking the square root of the sum of the squared components of each embedding. The division of the dot product by the product of the magnitudes normalizes the similarity score to a value between 0 and 1. Prerequisites. A chroma vector store is a specialized data structure for storing and retrieving embeddings efficiently. It's a key component for building search and recommendation systems using vector similarity. Chroma is an open-source Python library that provides a robust framework for building and managing vector stores. It offers functionalities for embedding storage, similarity search, and data management. Fine-tune parameters. There are no specific parameters for fine-tuning the cosine similarity calculation itself. However, the embeddings used as input might be fine-tuned based on the specific domain or task. Challenges and fixes. In some cases, embeddings of semantically similar text might yield a low cosine similarity score. This can occur if the embedding model is not adequately trained to capture the nuances of a specific domain, or if the vector store has not been optimized for the desired similarity criteria. Switching to different embedding models that are better suited for the given task or exploring alternative vector stores could address this challenge. Conversely, embeddings of semantically dissimilar text might produce a high similarity score. This could happen if the embedding model has inherent biases or if the vector store is not properly configured. Reviewing the chosen embedding model and potentially trying different models, as well as carefully examining the configuration of the vector store, can help to mitigate this issue. Langchain cohere chat models get cohere chat request. This function constructs a cohere chat request, which is a JSON formatted object containing the chat history and the current user input, based on the input text and chat history provided. This request is then sent to the Cohere API, a service that provides natural language processing capabilities like conversational AI. Inputs. Text that represents past conversations with the conversational AI, which is sent to Cohere's application programming interface API, is part of the chat history. This history is used to provide context for the current user input and helps the AI understand the flow of the conversation. For example, if the user asks what is the capital of France, the chat history might include previous interactions like what country are you from? And I am from France. This gives the AI context to understand the current question. Text that represents the current user's input, which is sent to Cohere's application programming interface API. This is the prompt that triggers the AI to generate a response. For example, the user might type "What is the capital of France?" as the current user input. Outputs. A JSON formatted Cohere chat request object that is sent to Cohere's application programming interface API. This object contains the chat history and the current user input, which the API uses to generate a response. The format of this JSON object is defined by Cohere and is specific to their API. Steps. Iterate through each message in the chat history, creating Cohere chat history entries for each one. A Cohere chat history entry contains the role of the speaker, user, or assistant and the text of the message. These entries help the Cohere API understand the context of the conversation. Construct a dictionary that includes all the chat history entries and the current user input. This dictionary is used to create the JSON formatted Cohere chat request object. Convert the dictionary into a JSON string that can be sent to Cohere's application programming interface API. The API requires the request to be in this specific format for it to process the information correctly. Prerequisites: a valid Cohere application programming interface API key. This key is required to authenticate with the Cohere API and allows you to use their services. You can get a Cohere API key by signing up for a Cohere account on their website. Cohere.api key your API key. The name of the Cohere chat model you want to use. This model is responsible for generating responses to the user's input. Cohere provides various chat models with different capabilities. For example, the Cohere chat model is a general-purpose conversational AI model that can be used for a wide range of tasks. Model Cohere chat. Fine-tune parameters. A parameter that controls the randomness of the generated responses. A higher temperature value will result in more creative and unpredictable responses, while a lower temperature will produce more consistent and predictable responses. This parameter allows you to fine-tune the IS behavior and adjust its output according to your needs. For example, if you want the AI to be more creative and surprising, you can increase the temperature. The maximum number of tokens that the AI can generate in response to a user input. This parameter allows you to control the length of the generated responses. A higher max tokens value will allow for longer responses, while a lower value will limit the length of the response. For example, if you want the AI to give short and concise responses, you can set a lower max tokens value. Challenges and fixes. Cohere's application programming interface API has rate limits that restrict the number of requests you can send within a given time period. If you exceed these limits, your requests will be rejected. Increase your rate limit by contacting Cohere support. Cohere support can help you increase your rate limit if you are using the API for a legitimate purpose and need to make more requests. Sometimes, you may encounter errors when sending requests to Cohere's application programming interface API. These errors can be caused by a variety of factors, such as network issues, server problems, or invalid requests. Check the error message for more information about the issue. If you are unable to resolve the issue yourself, you can try again later or contact Cohere support for assistance. Langchain Cohere chat models get role summary. This document describes the process of obtaining the role of a Cohere chat model using langchain. Langchain is a framework for building applications that use large language models. Name of the Cohere chat model to be used in the operation. This is the name of the pre-trained language model from Cohere that is used for the task. The model name is used to identify the specific language model to be used for the task. For example, command X large nightly. Application programming interface key API key required to access the Cohere API and use the Cohere chat models. This key is used for authentication and authorization to access the Cohere platform and its services. API keys are obtained from the Cohere website. This output is the role of the Cohere chat model. This role indicates the intended use of the model and is associated with its training data. The roles can include chat, summarization, translation, etc. This helps understand the model's strengths and limitations. Create an instance of the Cohere chat model using the langchain framework. This is done by using the provided Cohere API key in the specified Cohere chat model name. The process involves initializing a Cohere chat model object within the langchain environment. Utilize the getRole method on the initialized Cohere chat model object to retrieve the role associated with that model. The getRole method is part of the langchain framework's interface for interacting with Cohere chat models. It provides a standardized way to access the role information from the model. Application Programming Interface Key. A API key is required to access and use the Cohere platform and its services. This key is obtained from the Cohere website. The API key acts as a credential for authenticating and authorizing the user's access to Cohere's services. A Cohere chat model name that is available for use. This name identifies a pre-trained language model from Cohere that is used for the task. The available model names are publicly documented on the Cohere website and can be chosen based on the specific requirements of the task. This operation does not involve fine-tuning parameters. This indicates that the operation uses pre-trained Cohere chat models without any further customization or training. The focus is on obtaining the role of an existing model. If the application programming interface key API key provided is incorrect, it will result in an error when attempting to access the Cohere API. The API key is crucial for authenticating and authorizing access to Cohere services. And an invalid key will prevent successful interaction with the API. The solution is to verify the API key by checking it on the Cohere website and rerunning the code after ensuring it is correct. If the specified Cohere chat model name is invalid, it will result in an error when attempting to create an instance of the Cohere chat model. This could happen if the model name is misspelled, does not exist in Cohere's model library, or is not publicly available. The solution is to check the model name against the list of available Cohere chat models and use a valid model name. Langchain Chroma Vector stores cosine similarity, a tool that allows users to interact with a Python read eval print loop within a langchain session. The tool provides an interactive environment where users can execute Python code snippets and receive immediate results. This enables users to perform calculations, analyze data, and explore Python libraries within the context of a langchain session. Inputs. User input provided as Python code. Users can enter Python code snippets that are valid Python syntax, which the tool will then execute. The input can include any valid Python code, such as variable assignments, function calls, library imports, and more. Outputs. The output of the Python code execution. The tool returns the result of executing the provided Python code. The output can be in various formats, depending on the executed code, including text, numeric values, lists, dictionaries, and other Python objects. Steps. The tool receives the user's Python code. The tool takes the user's Python code as input, ensuring that it is valid Python syntax. The tool executes the code in a Python read eval print loop environment. The tool provides a runtime environment where it can evaluate the provided Python code and produce results. The tool returns the output of the execution. After executing the Python code, the tool sends the results back to the user. The output is displayed in a human-readable format, making it easy to understand and interpret the results of the Python code execution. Prerequisites. Langchain session setup. A langchain session is necessary for the tool to function correctly. This means that a langchain session must be established before the tool can be used. A langchain session provides the context and environment for the tool to operate. Python environment. A Python environment with the necessary libraries installed is required for the tool to execute Python code. This ensures that the tool has access to the required modules and functions for running Python code. For example, the tool might need libraries like NumPy for numerical computations, Pandas for data analysis, or Matplotlib for plotting. Fine-tune parameters. None. The tool does not have any fine-tuning parameters, meaning that its behavior is fixed and cannot be adjusted through specific settings. Challenges and fixes. Error handling. The tool should be able to handle errors that might occur during Python code execution. For instance, if the user provides invalid Python syntax or calls a function that does not exist, the tool should provide informative error messages. Security considerations. Security measures are crucial to prevent unauthorized access to the Python read-eval-print loop environment. This ensures that only authorized users can execute code in the environment and that the tool cannot be used for malicious purposes. Security measures can include authentication mechanisms, access control policies, and sandboxing. Langchain Cohere Agent Summary. This agent uses Cohere's application programming interface API for language generation, comprehension, and summarization tasks in a langchain environment. Inputs. The agent processes user input, which can be text or prompts. The agent considers contextual information or previous interactions. Outputs. The agent produces generated text, summaries, or responses based on the user's input and the context. Steps. The agent receives user input. The input is pre-processed and prepared for Cohere's API. The input is sent to Cohere's API for processing. Based on the input and the specified task, Cohere's API generates output. The output is returned to the user through the langchain framework. Prerequisites. Cohere Application Programming Interface Key Cohere API Key. Installation of langchain. Pip install langchain. Fine-tune parameters. Selecting a Cohere model, e.g., command, generate. Cohere Application Programming Interface Endpoint. Challenges and fixes. Application Programming Interface Rate Limiting. Utilize a rate limiter to manage requests. Handling errors. Implement robust error handling mechanisms. Langchain Cohere Common. Utilizing Cohere Application Programming Interface for natural language processing tasks within langchain framework. This involves integrating Cohere's powerful language models and functionalities into the langchain ecosystem to perform tasks like text summarization, translation, question answering, and more. Inputs. Text input for processing. Typically a string. This could be a sentence, paragraph, or any text that needs to be processed by the Cohere Application Programming Interface. For example, the text input could be the quick brown fox jumps over the lazy dog. Cohere Application Programming Interface Key for authentication. This is a unique identifier provided by Cohere that grants access to their application programming interface services and ensures that your requests are properly authorized. You can obtain this key from your Cohere account. Outputs. Processed text output. Based on the specific task. This is the result of the Cohere Application Programming Interface processing the input text. For instance, if the task is text summarization, the output could be a concise summary of the input text, potential metadata, or additional information from the API response. This could include information like the model used for processing, the confidence level of the output, or any other relevant details returned by the Cohere Application Programming Interface. Steps. Initialize a Cohere wrapper object within langchain. This step involves creating an instance of a Cohere wrapper class within your langchain application, which acts as an interface to interact with the Cohere Application Programming Interface. Define the specific Cohere Application Programming Interface endpoint or function to use. This involves specifying which Cohere Application Programming Interface functionality you want to use, such as text summarization, translation, or question answering. Each function or endpoint is designed to perform a specific task. Pass the input text to the chosen Cohere function. This involves providing the input text to the selected Cohere Application Programming Interface. Function for processing. Process the API response. Extracting the relevant output. This involves handling the response from the Cohere application programming interface, which typically includes the processed text output and any additional metadata. You'll then extract the desired information from the response. Prerequisites. Cohere application programming interface key. Obtained from Cohere platform. This key is essential for authenticating your requests to the Cohere application programming interface. You can obtain this key from your Cohere account. Langchain installation. Use pip install langchain. This ensures that you have the necessary langchain library installed to work with the Cohere application programming interface within your application. Fine-tune parameters. Model type for specific task. This parameter allows you to select the specific Cohere model best suited for your task. For instance, if you are performing text summarization, you might choose a model specifically trained for that purpose. Application programming interface request parameters for fine-grained control. This allows you to customize the behavior of the Cohere application programming interface by providing additional parameters such as maximum length for the output, temperature for randomness, or any other options specific to the chosen API function. Challenges and fixes. Application programming interface rate limits. Handle rate limits gracefully using back-off strategies. This involves implementing mechanisms to handle rate limits imposed by the Cohere application programming interface. Rate limits are designed to prevent excessive usage and ensure fair access for all users. Application programming interface response parsing issues. Ensure proper handling of application programming interface response format. You need to ensure that your application can correctly parse the responses returned by the Cohere application programming interface, which may include various data structures and formats. Cohere application programming interface errors. Implement error handling and retry mechanisms. This involves handling potential errors that might occur during interactions with the Cohere application programming interface. This could include implementing retry mechanisms to handle temporary network issues or server errors. Cohere citation in langchain. This YAML is a descriptive document of the Cohere citation tool, which is an integral part of langchain. It provides a detailed outline of the tool, including its purpose, functionalities, inputs, outputs, steps involved, prerequisites, customizable settings, potential challenges, and their solutions. This description details the purpose and function of the Cohere citation tool within langchain. It acts as a citation generator by utilizing the Cohere application programming interface API for text summarization to extract relevant information from provided documents and produce citations adhering to the specified format. Inputs. Document the input document that needs to be cited, representing the source material from which the citation will be generated. This document can be in various formats like text files, PDFs, or URLs, allowing the tool to handle diverse input types. Citation format. This input specifies the desired citation style for the generated citation, such as upper, MLA, or Chicago, ensuring consistency and adherence to established academic standards. For instance, a user might specify upper for a research paper or MLA for an essay. Outputs. Citation. This output represents the final generated citation in the specified format based on provided document and chosen citation style. The output aims to provide a concise and accurate representation of the source material for reference purposes. Steps. 1. Document processing. This step involves taking the input document and breaking it down into smaller, manageable segments. making the summarization process more efficient and effective. For example, a long article could be divided into paragraphs, allowing for more targeted analysis. 2. Summarization. This stage utilizes the cohere API to summarize each processed chunk of the document. Cohere's text summarization capabilities are employed to extract the most crucial information from each segment, providing a concise overview of the content. 3. Citation generation. Using the summaries generated in the previous step, the tool assembles a citation in the specified format. This step leverages the extracted key information to create a structured citation, ensuring proper attribution and adherence to the selected style guidelines. Prerequisites. Cohere API key. A valid Cohere application programming interface API key is a necessary requirement to use the Cohere citation tool. This key provides access to Cohere's services, including text summarization. For instance, obtaining a valid API key is crucial for initiating and executing the summarization process within the tool. Cohere API. This prerequisite indicates that the Cohere application programming interface API should be properly configured and readily accessible for the tool to function correctly. This ensures seamless communication and data exchange between the Cohere citation tool and the Cohere API for successful summarization and citation generation. Fine-tune parameters. Summarization model. This parameter allows users to specify the specific Cohere model used for summarization. By selecting a suitable model, users can tailor the summarization process to their specific needs, such as selecting a model that excels in extracting key information or providing comprehensive summaries. Citation style. This customizable parameter enables users to choose the specific citation style they want to use for the generated citations. Options like Upper, MLA, or Chicago allow users to comply with different academic formatting requirements. For example, a researcher working on a scientific paper might choose Upper while a student writing an essay might select MLA. Challenges and fixes. Challenge 1. Incorrect citation format. This challenge occurs when the generated citation does not adhere to the specified format. Fix 1. To address this, the user should verify that the citation style parameter is set correctly and ensure the Cohere model is trained to produce citations in the chosen format. For example, if the desired format is Upper, the user needs to double-check that the parameter is correctly set to Upper and that the Cohere model is capable of generating citations in that specific style. Challenge 2. Incomplete or inaccurate summaries. This challenge arises when the Cohere API produces summaries that are either insufficient or contain inaccuracies. Fix 2. To resolve this, the user can try adjusting the summarization model or modifying the parameters to achieve more comprehensive and accurate summaries. This might involve selecting a different Cohere model known for its ability to produce detailed summaries or adjusting the parameters to control the length or level of detail in the summaries. For example, increasing the max length parameter might lead to longer, more informative summaries. Langchain. Cohere Common. Langchain integration with Cohere, an application programming interface for natural language processing. For various tasks, inputs, text input for analysis, generation, translation, and other natural language processing tasks. For example, you might input a paragraph of text for summarization, a question for answering, or a sentence for translation. Cohere Application Programming Interface Key, obtained from the Cohere website, to authenticate requests to the Cohere service. Outputs. Processed text output, such as summaries, completions, translations, or other results from the Cohere application programming interface. For example, you might receive a summary of the input text, a generated continuation of the input text, or a translation of the input text into another language. Raw data returned by the Cohere application programming interface, containing details about the request and response, such as the model used, the processing time, and the API response code. Steps. Initialize langchain, a framework for building and deploying language models, with the Cohere application programming interface key for authentication and access to the Cohere service. Define the specific natural language processing task to be performed by the Cohere application programming interface. For example, summarization, question answering, translation, or text generation. Use langchain to interact with the Cohere application programming interface, sending the input text and the defined task to the Cohere service. Process the raw data returned by the Cohere application programming interface, extracting and formatting the desired output, such as the processed text, and returning the results. Prerequisites. Cohere application programming interface key. Obtain from the Cohere website to authenticate requests to the Cohere service. Langchain library installed. Install the langchain library using the command pip install langchain. Fine-tune parameters. Cohere model type. Selecting the specific Cohere model to use for the task. For example, different models might be optimized for summarization, question answering, or translation. Temperature for generation. Controlling the randomness or creativity of the output, ranging from 0 to 1. With higher values leading to more surprising outputs. Maximum tokens for output. Limiting the length of the generated text or other responses to a specific number of tokens. Which are the fundamental units of text in language models? Challenges and fixes. Incorrect Cohere application programming interface key. Verify the Cohere application programming interface key and check the Cohere documentation for correct format and instructions. Rate limiting issues. Encountered when exceeding the allowed number of requests to the Cohere application programming interface within a specific time frame. Reduce request frequency to comply with the rate limits. Or consider using a proxy to distribute requests across multiple connections, potentially avoiding rate limiting issues. Model-specific limitations. Inherent to the capabilities and limitations of the chosen Cohere model. Consult the Cohere documentation for details on specific model capabilities, limitations, and recommended use cases. Unexpected application programming interface errors. Arising from various reasons, such as network issues, service outages, or unexpected input data. Check the Cohere status page for any known service issues. Debug API calls for errors. And consult the Cohere documentation for troubleshooting tips. Langchain Cohere Common Cohere Citation Summarization. This component assists with citing sources in the output of a language model. It takes the text generated by the model and the source information, and generates a properly formatted citation. This is useful for ensuring the accuracy and integrity of the generated content, as well as giving credit to the original sources of information. Inputs. Text from the language model output. This is the text that the model has generated, and may contain information that needs to be attributed to a specific source. The source to cite. This is the source of the information that the model used to generate the output text. It could be a website, a book, a journal article, or any other type of source. The source should be provided in a format that allows the component to extract the necessary information for the citation, such as a URL, DOI, or bibtex entry. Outputs. A citation from the provided source. This is a properly formatted citation that can be used to attribute the information in the model. Output to the original source. The citation will be formatted according to the specified citation style. Steps. Extract the text from the model output. This step involves identifying the relevant text from the model's output that needs to be attributed to a source. Format the citation from the source. This step involves using the source information provided, along with the specified citation style, to generate a properly formatted citation. Prerequisites. A source from which to generate a citation. This could be a URL, DOI, or bibtex entry. For example, a URL might be https www. Example, com article. A DOI might be 10.1038 S41586023062236. And a bibtex entry might be article title. Author. A. Title article title. Journal title. Year 2023. Volume 38. Pages 123,145. A language model that provides text output. This could be a model like TextDaVinci 003 or CodeDaVinci 002, which are both available through the OpenAI Application Programming Interface API. Fine-tune parameters. Citation style. This specifies the format of the citation, such as MLA, Upper, Chicago, or Harvard. The citation style determines the order of the elements in the citation, such as author, year, title, and journal. Output format. This specifies the format in which the citation is returned. It could be plain text, HTML, or another format that is suitable for the intended use of the citation. Challenges and fixes. Incorrect format of citation. This could be due to an error in the source information or an incorrect specification of pay. Citation style. To fix this, ensure that the source information is correct and that the citation style is specified correctly. Citation not present in output. This could be due to a lack of information in the input text or a failure to properly identify pay. Relevant text. To fix this, add more information to the input text or adjust the text extraction process to ensure that pay relevant text is captured. Cohere citation in langchain. NaN. A langchain component that leverages the Cohere Application Programming Interface API to generate citations. Inputs. A textual document that you want to summarize. The preferred citation style for the generated citations, such as Upper or Chicago. Outputs. A collection of citations formatted according to the chosen citation style. Steps. The input text is transmitted to the Cohere API. Cohere generates citations based on the provided text and the specified citation style. Prerequisites. A Cohere API key. You can obtain an API key from Cohere's website. The langchain library must be installed. Use the command pip install langchain to install langchain. Fine-tune parameters. Model the particular Cohere model you want to use. Max citations. The maximum number of citations you want to generate. Challenges and fixes. Incorrect citation formatting. Make sure the correct citation style is provided. Citations are missing or incomplete. Consider increasing the max citations parameter or adjusting the input text to address this. Langchain Cohere LLMS Base Cohere. This is a base class for Cohere large language models. It defines the core functionalities and components common to all Cohere LLMs. Inputs. Text to be processed by the Cohere large language model. This can be a sentence, paragraph, or any text string. Outputs. The output of the Cohere LLM, typically a text response generated based on the input text. Steps 1. Initialize Cohere Application Programming Interface Client. This step involves creating a connection to the Cohere Application Programming Interface using the Cohere library. 2. Send request to Cohere Application Programming Interface. This step sends the input text to the Cohere API for processing. 3. Process response from Cohere Application Programming Interface. This step retrieves and processes the response received from the Cohere API. It involves extracting the generated text output and any other relevant information. Prerequisites 1. Cohere Application Programming Interface Key. This is a unique key provided by Cohere to authenticate your access to the Cohere API. You can obtain this key by registering on the Cohere website. Obtain your Cohere Application Programming Interface key from the Cohere website. You can find it in your account dashboard or settings. 2. Cohere Application Programming Interface Client. This refers to the Cohere library, which provides Python functions and tools for interacting with the Cohere API. You need to install this library using pip install cohere. Install the Cohere library using pip install cohere in your Python environment. This library provides the necessary functions and tools to interact with the Cohere API. Fine-tune parameters. 1. Model. This parameter specifies the Cohere model you want to use for processing the input text. Cohere offers various models with different capabilities and strengths. 2. Temperature. This parameter controls the creativity and randomness of the generated text output. Higher temperatures result in more diverse and less predictable responses, while lower temperatures produce more coherent and deterministic outputs. 3. Max tokens. This parameter sets the maximum number of tokens that the Cohere model can generate in response to the input. Tokens represent individual units of text, like words or punctuation marks. 4. Top P. This parameter controls the probability distribution of the generated tokens. It determines the likelihood of selecting a specific token based on its predicted probability. 5. Top K. Similar to top P, this parameter controls the distribution of generated tokens, but it focuses on the top K most likely tokens. Challenges and fixes. 1. Handling errors from Cohere Application Programming Interface. The Cohere API might encounter errors during processing, such as network issues or invalid input. This challenge involves handling these errors gracefully by checking for API errors and implementing error handling mechanisms like retrying the request. Use try-except blocks in your code to handle potential errors from the Cohere API. Check for specific API error codes and retry the request with exponential backoff if necessary. 2. Managing Application Programming Interface Rate Limits. Cohere imposes rate limits on API requests to prevent abuse and ensure service stability. This challenge involves managing these rate limits by implementing strategies like exponential backoff to avoid exceeding the allowed request rate. Use exponential backoff to space out your requests and avoid exceeding the Cohere API rate limits. This involves increasing the delay between requests exponentially with each failure. 3. Handling long input text. Long input texts can exceed the maximum input length allowed by the Cohere API. This challenge involves breaking down the input text into smaller chunks to ensure it fits within the API limits. Break down long input texts into smaller chunks before sending them to the Cohere API. You can use techniques like sentence segmentation or text splitting to create manageable chunks. 4. Customizing model behavior. The Cohere LLM offers various parameters that allow you to customize its behavior and fine-tune its output. This challenge involves leveraging these parameters to tailor the model's output to your specific needs. Experiment with different values for parameters like temperature, max tokens, top P, and top K to fine-tune the model's creativity, output length, and token distribution. Langchain cohere agent. The langchain cohere agent is a tool designed to leverage the power of cohere's application programming interface API for tasks related to language generation and understanding within a langchain framework. Inputs. The agent accepts user prompts or questions, serving as the starting point for its language processing operations. In addition to prompts, the agent can also take in contextual information or knowledge bases. This information can be used to enhance the generated responses and provide more relevant and informative outputs. Outputs. The agent produces textual responses generated using Cohere's powerful language models. These responses are tailored to the input prompts and contextual information provided. Beyond just text, the agent can also output structured data or insights derived from the generated responses. This capability allows for more versatile applications and enables users to extract valuable information from the generated content. Steps. The agent begins by receiving user input or a prompt. This is the initial step that triggers the agent's processing pipeline. The agent then preprocesses the input and integrates any contextual information provided. This preprocessing step ensures that the input is properly formatted and ready for processing by Cohere's models. The processed input is then submitted to Cohere's application programming interface API for text generation or understanding tasks. This step leverages Cohere's advanced language models to generate responses or extract insights from the provided input. The agent processes the response received from Cohere's API and extracts relevant information. This involves analyzing the generated text, identifying key entities, relationships, and other important aspects of the response. Finally, the agent formats and returns the output to the user. This involves presenting the extracted information in a clear and concise manner, potentially including both textual and structured data elements. Prerequisites. A valid Cohere application programming interface API key is essential for accessing and utilizing Cohere's language models within the langchain agent. Obtain a Cohere API key by registering on their website and accessing your account dashboard. The langchain framework must be installed and configured properly for the agent to function. Use the Python package manager pip to install langchain. The command pip install langchain will install the necessary packages. Fine-tune parameters. The agent offers the flexibility of selecting a specific Cohere model based on the desired task and desired level of accuracy. This allows for fine-tuning the agent's capabilities to suit specific use cases. The temperature parameter controls the level of creativity and randomness in the generated responses. A higher temperature value leads to more creative and unpredictable outputs, while a lower value produces more deterministic and coherent responses. The max tokens parameter allows you to specify the maximum length of the generated response. This helps control the length of the output and avoid excessively long responses. The top K parameter determines the number of candidate words that are considered at each step. During text generation, a higher value of top K increases the diversity of the generated text, while a lower value makes the output more focused. The top P parameter is another mechanism for controlling the diversity of the generated text. It sets a probability threshold for selecting the next word. Words with higher probabilities have a better chance of being selected, leading to more predictable outputs. Challenges and fixes. One potential challenge when using application programming interfaces APIs is rate limiting. API providers often impose limits on the number of requests that can be made within a specific time frame. To address this challenge, implement rate limiting logic in your code. This involves tracking the number of API calls made and pausing or slowing down requests if the limit is nearing. Cohere's application programming interface API may impose limits on the length of the responses generated. Adjust the max tokens parameter to control the maximum length of the generated response, ensuring that it stays within the API's limits. Integrating contextual information into the generated responses can be a challenge. Leverage langchain's retrieval capabilities to effectively access and integrate relevant context from external knowledge sources, enhancing the quality and relevance of the generated outputs. Formatting the output in a user-friendly and structured way can be crucial. Utilize langchain's output parsing tools to extract desired data from responses generated by coheres API. This allows for more efficient and structured presentation of the results to the user. Cohere LLM-based text generation with retry mechanism. NaN. Cohere is a powerful large language model LLM developed by cohere.ai. It excels in various natural language processing tasks, including text generation, language translation, creative content writing, and providing informative answers to questions. Cohere is designed to be versatile and adaptable, making it suitable for a wide range of applications. Inputs. Text input to the Cohere model, serving as the basis for the LLM's processing. This input can be a sentence, paragraph, or even a longer text document, depending on the specific task. For instance, you might input a news article to generate a summary, or a poem to create a continuation in the same style. Temperature parameter. Controlling the randomness and creativity of the generated text. A higher temperature value leads to more unpredictable and potentially surprising outputs, while a lower value results in more predictable and coherent responses. This allows fine-tuning the model's output to match the desired level of creativity and diversity. For example, a high temperature setting might be suitable for generating fictional stories, while a low temperature setting is more appropriate for factual summaries or translations. Outputs. Text generated by the Cohere model based on the provided input and parameters. The output can take various forms depending on the task, such as a summary, translation, creative text, or an informative answer. For example, an input describing a historical event might result in a detailed summary, while a query about a scientific concept could produce a comprehensive explanation. Steps. The generate method of the Cohere Python library is the primary interface for interacting with the Cohere model. This method takes the input text and various parameters, including the temperature value, and uses the Cohere LLM to produce the desired output. The generate method encapsulates the complex underlying operations of the LLM, allowing users to interact with the model in a straightforward manner. The temperature parameter, as explained earlier, plays a crucial role in shaping the creativity of the generated text. By adjusting the temperature value, users can fine-tune the model's output to match their specific requirements. For example, a low temperature setting might produce more concise and factual responses, while a high temperature setting could lead to more creative and imaginative outputs, including poems, scripts, or stories. Prerequisites. Cohere Application Programming Interface API key. Essential for accessing the Cohere model's capabilities. Obtaining an API key typically involves signing up for a Cohere account and following the instructions provided on their website. The API key acts as a unique identifier, allowing authorized users to interact with the Cohere model and utilize its functionalities. Cohere Python Library, a software package providing a convenient interface for integrating Cohere's functionalities into Python applications. The library simplifies the process of using the Cohere model by offering high-level functions and methods for accessing and interacting with the LLM. It can be installed using the pip package manager, a standard tool for installing Python libraries. Fine-tune parameters. Temperature, as described earlier, offers flexibility in controlling the creativity and randomness of the generated text. By adjusting the temperature value, users can fine-tune the model's output to suit their specific needs. For example, in a creative writing application, a higher temperature might be desired to produce more surprising and unexpected results. While in a factual summary task, a lower temperature could be more suitable for maintaining coherence and accuracy. Max tokens, a parameter that limits the maximum number of tokens words or subword units in the generated output. This parameter allows users to control the length of the generated text, preventing excessive output while maintaining a balance between brevity and comprehensiveness. For example, in a text summarization task, a maximum token limit could be set to ensure that the summary remains concise and relevant to the original text. Challenges and fixes. Cohere Application Programming Interface API rate limits. Restrictions on the number of requests that can be made to the Cohere model within a given time frame. These rate limits are implemented to ensure fairness and prevent abuse of the model's resources. It is essential to be aware of these limits and plan accordingly to avoid exceeding them. Strategies for managing rate limits include scheduling requests, implementing request queuing, or using a caching mechanism to reduce the number of API calls. Cohere Application Programming Interface API errors. Potential issues that can occur during interaction with the Cohere model. These errors can arise due to various reasons, such as invalid API keys, network connectivity problems, or server unavailability. It is crucial to handle API errors gracefully to ensure the robustness and reliability of the application. This involves implementing error handling mechanisms to detect and manage errors, provide informative error messages, and attempt to recover from errors when possible. By proactively addressing potential errors, applications can maintain stability and provide a consistent user experience. Langchain Cohere LLMS Base Cohere. This is a description of the base Cohere LLM wrapper within the langchain framework. This wrapper acts as a bridge between the langchain library and the Cohere application programming interface API. Essentially, this wrapper allows developers to leverage the powerful capabilities of Cohere's language models within the langchain ecosystem. Inputs. This represents the text input that is provided to the Cohere language model. This input can be anything from a simple question to a lengthy paragraph of text. For instance, you might provide the following as an input: what is the capital of France? Or write a short story about a cat named Mittens. The temperature parameter controls the randomness of the generated text. Higher values closer to 1 lead to more creative and unpredictable output, while lower values closer to 0 produce more deterministic and predictable text. In simpler terms, a higher temperature makes the model more adventurous in its writing, while a lower temperature makes it stick closer to expected norms. The maximum number of tokens that the model is allowed to generate. A token is a unit of text, typically a word or a punctuation mark. This parameter helps control the length of the generated text, preventing the model from generating excessively long responses. For example, You might set max tokens to 50 to ensure that the generated text doesn't exceed 50 tokens. This parameter defines the number of top-ranked candidate tokens to consider when generating text. A higher value increases the model's exploration of potential words, leading to potentially more diverse and unexpected outputs, though it might also result in less coherent responses. A lower value makes the model more focused on the most likely candidates, leading to smoother and more predictable outputs. This parameter is similar to top K, but it controls the probability distribution of the top-ranked candidate tokens. A higher value closer to 1 allows for a broader range of probabilities, making the model more likely to generate less common words or phrases. A lower value closer to 0 narrows down the probability distribution, resulting in more predictable and conventional outputs. Outputs: the generated text output from the Cohere language model, based on the provided input and fine-tuning parameters. Steps: this step involves initializing the Cohere API client. This process essentially establishes a connection between your code and the Cohere API, allowing your program to send requests and receive responses from the Cohere servers. This connection is typically made through a library or SDK provided by Cohere, which simplifies the communication process. The Cohere generate endpoint is invoked with the input text and any specified fine-tuning parameters. This endpoint represents the core functionality of the Cohere API, responsible for generating text based on the provided input. This step essentially asks the Cohere model to process the input and generate a text response based on its learned knowledge and the provided parameters. Prerequisites: a Cohere application programming interface API key is required to access and utilize the Cohere API. This key acts as a unique identifier and authorization token, granting access to the Cohere services for your application. You can obtain your API key from the Cohere website by creating an account and navigating to the API key settings. The Cohere Python library is a software package that simplifies the interaction with the Cohere API. From Python code, this library provides functions and classes that encapsulate the complexities of interacting with the API, making it easier to send requests, receive responses, and manage authentication. Installing this library is usually done using the pip package manager. Fine-tune parameters. This parameter, as explained earlier, controls the level of randomness in the generated text. By adjusting this parameter, you can fine-tune the model's creativity and unpredictability, making it generate text that is either more explorative or more consistent with expected patterns. This parameter governs the maximum length of the generated text in terms of tokens. By adjusting this parameter, you can control the output length, ensuring it remains within desired limits. This parameter determines the number of top-ranked candidate tokens to consider during text generation. It influences the exploration of potential words, impacting the diversity and unexpectedness of the generated text. This parameter works similarly to top K, but it controls the probability distribution of the top-ranked candidate tokens, influencing the likelihood of less common words or phrases appearing in the output. Challenges and fixes. The Cohere API, like many online services, might impose rate limits to prevent excessive usage. This means that you can only make a certain number of requests within a given time period. If your program exceeds the limit, it might experience delays or errors. A common approach to handling rate limiting is to implement a retry mechanism, where your program automatically retries the request after a short delay if it encounters an error due to rate limiting. This allows your application to continue functioning even if it temporarily exceeds the rate limit. Network connectivity issues are another potential challenge when interacting with an online API. These issues can arise from various factors, such as temporary network outages, firewall restrictions, or even unstable internet connections. To mitigate these issues, you should implement robust error handling mechanisms in your code. This involves detecting network errors, providing informative messages to the user, and potentially attempting to reconnect or retry the request after a short delay. Incorrect or invalid API keys are a common source of problems when interacting with online APIs. If your API key is incorrect or has expired, your requests will likely fail. Therefore, it's crucial to carefully check your API key and ensure it is valid and properly configured. Additionally, you should always use a secure method of storing your API key to prevent unauthorized access. The Cohere API, like any online service, can occasionally become unavailable due to technical issues, maintenance, or other unforeseen circumstances. If the API is unavailable, your requests will fail. To handle this situation, you should implement a waiting and retry mechanism in your code. This involves periodically checking the API's status and retrying your request after a short delay. If it remains unavailable, this ensures that your program can recover from temporary API outages and continue functioning once the service becomes available again. Langchain Cohere LLMs Cohere. Cohere is a large language model LLM that can be used with langchain. It is a powerful tool for generating creative text formats, like poems, code, scripts, musical pieces, email, letters, etc., and translating languages. Inputs: text provided as input for the model to process. Outputs: the output of the model, in text format. Steps: initialize a Cohere model with an application programming interface API key for authentication and authorization. Generate text using the model with a prompt. Prerequisites: an application programming interface API key for accessing the Cohere services. You can obtain this key by creating a Cohere account. A Cohere account is required to obtain an application programming interface API key. Fine-tune parameters. Temperature controls the randomness of the generated text. The maximum number of tokens that can be generated in a single request. Challenges and fixes. Ensure the application programming interface API key is valid and the account is active. If you encounter rate limiting, reduce the frequency of your requests. Langchain Cohere RAG Retrievers Summarization. NAN. A specialized retriever built upon Cohere's large language model LLM for efficient document retrieval based on natural language queries. Cohere's RAG retrieval augmented generation capabilities empower users to retrieve relevant information from extensive document collections using natural language queries. Inputs: query a natural language question or statement that represents the user's information need. For instance, a user might input a question like "What is the capital of France?" Documents: a collection of text documents that serve as the knowledge base for the retrieval system. This could be a set of articles, books, or any other textual content. Outputs: relevant documents: a ranked list of documents from the input collection that are most relevant to the provided query. These documents are ranked based on their similarity to the query's vector representation. Steps: 1. Query encoding: the input query is transformed into a vector representation using a pre-trained language model like Cohere's embedder. This vector captures the semantic meaning of the query. 2. Document encoding: each document in the collection is also encoded into a vector using the same embedder. This process captures the semantic meaning of each document. 3. Similarity calculation. The vector representations of the query and each document are compared to calculate their similarity. This comparison is often done using a metric like cosine similarity, which measures the angle between the vectors. 4. Retrieval documents are ranked based on their similarity scores. The documents with the highest similarity scores are deemed most relevant to the query and are returned to the user. Prerequisites. Cohere Application Programming Interface Key. A valid Application Programming Interface (API) key is required to access Cohere's large language models (LLMs) and their associated services, including the embedder. The API key acts as an authentication token, granting access to Cohere's platform and its resources. Cohere API key. This is the unique alphanumeric code provided by Cohere to identify and authorize your application's access to their services. Cohere Embedder. A Cohere Embedder instance is required to encode queries and documents into vector representations. The embedder is a pre-trained language model specifically designed for transforming text into dense vector representations that capture the semantic meaning of the text. Fine-tune parameters. Top K. The number of documents to retrieve from the collection. This parameter determines the desired length of the retrieved document list. For example, a top K value of 10 would retrieve the top 10 most relevant documents. Similarity metric. The metric used to compare the vector representations of the query in documents. Common similarity metrics include cosine similarity, Euclidean distance, and Manhattan distance. These metrics calculate the degree of resemblance between the vectors, allowing the system to rank documents based on their semantic similarity to the query. Challenges and fixes. Challenge 1. Inefficient document encoding for large document collections. Processing large document collections can be computationally demanding, especially when using dense vector representations. This inefficiency can lead to slower retrieval speeds and increased processing times. Fixes to challenge 1. Consider using techniques like sparse vector representations or document chunking. Sparse vector representations can reduce the computational complexity of encoding large documents by storing only the most important features. Document chunking involves dividing large documents into smaller, manageable chunks, which can be processed independently and then combined for retrieval. Challenge 2. Limited context length. Cohere models, like many language models, have a limited input length. This limitation can pose a challenge when dealing with lengthy documents that exceed the model's capacity. Fixes to challenge 2. Break down large documents into smaller chunks. This approach allows the model to process each chunk individually, overcoming the input length constraint. The retrieved chunks can then be combined to provide a complete and comprehensive answer. Langchain Cohere LLMs base Cohere. A wrapper for Cohere language model LLM built using langchain. Designed to streamline the interaction and utilization of Cohere's capabilities within various applications. Langchain is a framework that simplifies the integration of large language models like Cohere into your project's inputs. A text input that serves as the prompt or query for the Cohere LLM. For example, a user question or a creative writing prompt. Outputs. The generated text output from the Cohere LLM in response to the provided input. The output can range from factual responses to creative narratives depending on the prompt. Steps. Establish a connection with the Cohere LLM through its Application Programming Interface (API) using the Cohere client. This involves initializing the Cohere client with necessary credentials and configurations to ensure secure and authorized communication. Invoke the Cohere generate method. which is responsible for processing the input text and generating a response from the cohere LLM. This method typically requires specifying parameters like temperature, maximum tokens, and other settings to fine-tune the generation process. Prerequisites: a valid cohere API key is required for authentication and access to the cohere LLM. This key is obtained from Cohere after creating an account and can be found in your account. Settings: the Cohere Python client library is a software package that provides the necessary tools and functions to interact with the Cohere API from Python code. It enables developers to seamlessly integrate the Cohere LLM into their Python projects. Fine-tune parameters: a parameter that controls the randomness and creativity of the generated text. Higher values lead to more unpredictable outputs, while lower values result in more predictable and deterministic responses. For instance, a temperature of 0.5 might produce more factual and consistent results, while a temperature of 1 could lead to more diverse and creative outputs. A limit on the maximum number of tokens that the Cohere LLM can generate in a single response. This parameter helps control the length and complexity of the generated text. It's important to set an appropriate maximum token limit based on the desired output length and computational resources available. A parameter that determines the number of top candidate tokens to consider during the generation process. Higher values lead to more diverse outputs by exploring a wider range of potential tokens. It's a trade-off between diversity and computational efficiency, as higher values can increase processing time. A parameter that controls the probability threshold for selecting tokens during the generation process. It restricts the selection to tokens whose probability exceeds the specified threshold, effectively focusing on the most probable options. A penalty applied to tokens that have already appeared frequently in the generated text. It discourages repetition and encourages more diverse and engaging content. A penalty applied to tokens that appear in the generated text based on their presence in the input prompt. This helps prevent the model from simply copying the prompt verbatim and encourages more original content generation. Challenges and fixes: ensure that the API key is correct and that there is a stable internet connection. If there is a connection error, you can try re-entering the API key or checking the internet connection. If the internet connection is unstable, you might consider using a VPN or a different internet provider. Ensure that the text input format is compatible with the Cohere LLM's requirements. For instance, Cohere may expect a specific format for questions or creative writing prompts. Refer to the Cohere documentation for the recommended input format. If you encounter unexpected API responses, it's helpful to check the Cohere API documentation or contact their support team. You can also try adjusting the parameters used for text generation, such as temperature, maximum tokens, and other fine-tuning settings, to see if that addresses the issue. It's a good practice to experiment with different parameters to find the optimal settings for your specific use case. Langchain Cohere Common Cohere Citation Summary. None. A langchain component that enables the use of Cohere's citation generation capabilities for text. This component allows you to leverage Cohere's advanced natural language processing capabilities to automatically generate citations for given text, enhancing the accuracy and credibility of your content. Inputs. Text: the input text for which you want to generate citations. This text can be a paragraph, a document, or any other piece of writing. Outputs. Citations: a list of generated citations that correspond to the information presented in the input text. These citations provide references to the original sources of the information, ensuring proper attribution and credibility. Steps. Use Cohere Citation Generation Application Programming Interface API to generate a list of citations for the given input text. The API leverages Cohere's powerful language models to analyze the text and identify relevant sources for the information contained within. Prerequisites. Cohere API key, a unique identifier that allows you to access Cohere's Citation Generation API. This key is required to authenticate your requests and ensure that you have the necessary permissions to use the API. You can obtain a Cohere API key by signing up for a Cohere account. Fine-tune parameters. Model the Cohere model to use for citation generation. Cohere offers various models with different strengths and capabilities. You can select the model best suited for your specific use case and the type of content you are working with. Temperature controls the randomness of the output citations. A higher temperature value introduces more randomness and variation in the generated citations, while a lower temperature value produces more consistent and predictable citations. Challenges and fixes. Missing citations. The model may not generate all relevant citations for the given input text. This can occur when the input text contains ambiguous or complex information that is challenging to associate with specific sources. Ensure the input text is clear and concise. Carefully review and revise the input text to ensure that it is well written and unambiguous. This will help the model accurately identify the information and generate relevant citations. Use a more robust citation generation model. Explore different Cohere models that are specifically trained for citation generation. These models are often equipped with advanced capabilities to handle complex text and generate more comprehensive citations. Incorrect citations. The generated citations may be inaccurate or irrelevant. This can occur when the model misinterprets the information in the text or when it encounters errors in the underlying data sources. Review and manually correct any incorrect citations. Always double-check the generated citations for accuracy and relevance. If you find any errors, manually correct them to ensure that the citations are reliable and provide accurate information. Fine-tune the model with specific citation examples for the desired domain. If you are working with a specific domain or subject matter, you can fine-tune the model with examples of citations from that domain. This will help the model learn the specific citation formats and references used in that area, leading to more accurate and relevant citations. Langchain Cohere React Multi-hop. A multi-hop question answering approach using Cohere for retrieval and React for reasoning. This approach combines the strengths of both Cohere and React to provide comprehensive and accurate answers to complex questions. Cohere is used for its powerful retrieval capabilities, extracting relevant documents from a given context, while React, a reasoning engine, analyzes these documents to generate a coherent and well-reasoned answer. This technique allows for a more nuanced understanding of the context and facilitates answering questions that require multiple steps of reasoning. Inputs. Question the question that the system aims to answer. This input provides the initial query that triggers the multi-hop question answering process. For example, a question could be, what is the capital of France? Context: the body of text or set of documents that the system uses to retrieve relevant information and answer the question. This can be a news article, a book, a set of documents, or any text corpus that contains the information needed to answer the question. For example, the context could be a Wikipedia article on France. Outputs. Answer: the final answer generated by the system based on the input question and the retrieved Context. This output is the product of the multi-hop reasoning process, where the system retrieves relevant information from the context and then uses React to reason over it to produce a comprehensive and accurate answer. For example, the answer to the question "What is the capital of France?" could be "The capital of France is Paris." Steps. Cohere is used for retrieving relevant documents from the context. This step involves using cohere's powerful retrieval capabilities to identify and extract relevant documents from the context that are related to the input question. Cohere uses its understanding of natural language to determine which documents are most likely to contain the information needed to answer the question. This is done by considering the keywords and phrases in the question and matching them with the documents in the context. For example, if the question is "What is the capital of France?" Cohere might identify documents containing the words France and capital as being relevant. React is used to reason over the retrieved documents to generate an answer once relevant documents have been identified. React is used to analyze and reason over their content to generate a comprehensive and accurate answer to the question. React utilizes its knowledge of language and logic to understand the relationships between the information in the documents and the question. This allows React to draw inferences, connect different pieces of information, and ultimately arrive at a reasoned answer. For example, if React identifies a document that states Paris is the capital of France, it can infer that the answer to the question "What is the capital of France?" is Paris. Prerequisites. Cohere Application Programming Interface Key. This is a unique identifier that grants access to Cohere's retrieval API. It allows the system to utilize Cohere's powerful retrieval capabilities to extract relevant documents from the context. To use Cohere's API, you will need to sign up for a Cohere account and obtain an API key. This key is specific to your account and allows you to access Cohere's services. React model. This is a pre-trained model that is used to perform reasoning over the retrieved documents. It's a powerful machine learning model specifically designed for reasoning tasks. This model is trained on a large dataset of text and code, enabling it to understand and reason over language. Different React models are available, each with varying levels of accuracy and complexity, depending on the specific reasoning task. Fine-tune parameters. Cohere retrieval parameters. These parameters control how Cohere performs retrieval and directly impact the quality of the retrieved documents. Fine-tuning these parameters can significantly improve the accuracy and relevance of the retrieved documents, ensuring that the system receives the most pertinent information to answer the question. This can include adjusting the number of documents to be retrieved, the relevance score threshold, and the specific retrieval model used. React reasoning parameters. These parameters control how React performs reasoning over the retrieved documents, impacting the quality of the final answer. Fine-tuning these parameters can improve the accuracy and completeness of the answer by optimizing the reasoning process. This can include adjusting the reasoning strategy used by React, the level of detail required in the answer, and the specific model used for reasoning. Challenges and fixes. Cohere retrieval may not return relevant documents in some cases. Cohere's retrieval process might fail to identify all relevant documents, leading to incomplete information being used by React for reasoning. This can result in inaccurate or incomplete answers. Fine-tune Cohere retrieval parameters to address this challenge. One can fine-tune Cohere's retrieval parameters, potentially improving the accuracy and completeness of the retrieved documents. This could involve adjusting the number of documents retrieved, the relevance score threshold, and the specific retrieval model used. By optimizing these parameters, you can ensure that Cohere retrieves the most relevant documents for the given question, increasing the likelihood of obtaining an accurate and complete answer. React may not be able to reason over the retrieved documents. There are instances where React might struggle to understand the relationships between the information in the retrieved documents, leading to an inability to reason effectively and generate an accurate answer. Fine-tune React reasoning parameters to overcome this challenge. Fine-tuning React's reasoning parameters can improve its ability to reason over the retrieved documents. This can involve adjusting the reasoning strategy, the level of detail required in the answer, and the specific model used for reasoning. By optimizing these parameters, you can enhance React's understanding of the relationships between the information in the retrieved documents, ultimately leading to more accurate and comprehensive answers. Cohere Tools React Agent Output Parser for multi-hop reasoning with langchain and cohere. None. The input for the agent is a natural language query. For example, the query could be "What is the capital of France?" The output from the agent is a JSON object containing the reasoning steps and final answer. For example, the output might include a step stating France is a country in Europe, followed by the final answer, Paris. The parser generates a structured representation of the agent's output. This representation encompasses the reasoning steps, intermediate results, and final answer. This structured representation might be a list of dictionaries, each dictionary representing a reasoning step with keys for the step description, the intermediate result, and the step's confidence score. A natural language summary of the reasoning process. For example, the summary could be: the agent determined that France is a country in Europe and then identified Paris as the capital. Extracts the reasoning steps from the agent's output. For example, the parser would extract France as a country in Europe as a reasoning step from the JSON output. Parses each reasoning step to identify the intermediate results. For example, the parser might identify Paris as an intermediate result from the step France is a country in Europe, and the capital of France is Paris. Combines the intermediate results and final answer into a structured representation. This structured representation could include a list of dictionaries, each representing a reasoning step. The dictionary for the final step would include the final answer. Generates a natural language summary of the reasoning process. This summary might be a concise explanation of how the agent reached its conclusion. For instance, the agent identified Paris as the capital of France based on its knowledge about countries and capitals. Cohere Application Programming Interface Key. This key is required to access Cohere's language models. Your Cohere API key. Langchain library. This library provides tools for building and integrating language models into applications. Your langchain library. The maximum number of reasoning steps to perform. This parameter sets an upper limit on the number of reasoning steps the agent can take to find the answer. For example, a value of 5 would limit the agent to 5 reasoning steps. The temperature parameter for the Cohere model. This parameter controls the randomness of the model's output. A higher temperature value will produce more creative and unexpected results, while a lower temperature value will produce more predictable and consistent results. For example, a temperature value of 0.5 will produce outputs with a moderate level of randomness, while a value of 1.0 will produce outputs with a high level of randomness. The agent may fail to find the correct answer due to insufficient context or ambiguity in the query. For example, if the query is "What is the capital of France?" and the agent has limited knowledge about France, It might struggle to identify the correct capital. Provide more context to the query. For example, the query could be revised to what is the capital of France? A country in Western Europe? Refine the query to be more specific. For example, the query could be rephrased to what is the name of the capital city of France? The agent may generate incorrect reasoning steps due to hallucinations or biases in the language model. For example, the agent might incorrectly state that France is a country in Asia or the capital of France is London. Verify the reasoning steps against external knowledge sources. For example, the parser could cross-reference the agent's steps with information from a trusted encyclopedia. Use a more reliable language model. For instance, the parser could switch to a model trained on a larger and more comprehensive dataset. Langchain cohere React multi-hop parsing parse actions summarization. This is the description of the langchain cohere React multi-hop parsing parse actions summarization functionality, which leverages Cohere's powerful large language model to answer multi-hop questions. Inputs. This refers to the user question that the system aims to answer. A user question is a query posed by the user to the system, seeking information or clarification on a specific topic. This signifies the set of documents that the system will utilize to extract information and answer the user's question. These documents can include various forms of text, such as articles, books, web pages, or any other relevant data source. Outputs. This represents the system's output, the answer generated to the user's question. It is derived from the analysis of the input documents and the application of the system's reasoning capabilities. Steps. This step involves parsing the user's question into a series of smaller, more manageable sub-questions. This is crucial for breaking down complex questions and simplifying the information retrieval process. Here, the system utilizes Cohere's large language model to answer each sub-question individually. This entails utilizing the model's extensive knowledge base and reasoning abilities to generate answers based on the input documents. This step entails combining the individual answers obtained for each sub-question into a cohesive, comprehensive final answer to the user's original question. This involves integrating the different pieces of information to provide a complete and insightful response. Prerequisites. This refers to the Cohere Application Programming Interface, a PKI. This key is necessary to access and utilize the capabilities of the Cohere large language model. It acts as an authentication mechanism, allowing the system to access the model's resources and functionality. Fine-tune parameters. This represents the model size, which refers to the computational capacity and complexity of the large language model employed in the system. Different model sizes offer varying levels of accuracy, performance, and resource consumption. Choosing the appropriate model size depends on the specific requirements and constraints of a application. This parameter refers to the number of sub-questions the system will generate from the user's original question. This value determines the depth and complexity of the analysis and influences the granularity of the information retrieval process. Challenges and fixes. This refers to the challenge of answering questions that require accessing and combining information from multiple sources or documents. This is often referred to as multi-hop reasoning. This outlines the solution to the challenge utilizing Cohere's built-in multi-hop reasoning capabilities. This empowers the system to follow a chain of reasoning, traversing multiple documents or sources to derive a final answer. This addresses the challenge of handling complex questions with intricate structures and relationships between different parts. These questions often require a sophisticated understanding of grammar, semantics, and context. This proposes a solution implementing a robust question parsing algorithm. This algorithm acts as the system's brain, analyzing the question structure and identifying the core components and their relationships to extract meaning and facilitate accurate information retrieval. This addresses the crucial challenge of ensuring the accuracy and reliability of the generated answers. It recognizes the importance of providing users with trustworthy and factual information. This provides a multifaceted solution utilizing a combination of techniques, including answer verification and evidence retrieval. Answer verification involves evaluating the plausibility and consistency of the generated answers based on the information extracted from the documents. Evidence retrieval seeks to identify and present supporting evidence from the documents, providing transparency and enhancing trust in the generated answers. Langchain cohere React multi-hop parsing parse answer with prefixes. A detailed explanation of how the method langchain cohere React multi-hop parsing parse answer with prefixes works. This method utilizes the cohere service for parsing answers from multi-hop questions, using a combination of text splitting, chunk identification, and language model chains. The goal is to break down the process of answering a multi-hop question into manageable steps, where cohere plays a crucial role in extracting relevant information from the provided text. Inputs. The text provided to the method should be formatted in a way that is easily parsable by cohere, such as a list of sentences or paragraphs. It is crucial that the text contains the answer to the question being asked. For example, one might provide a document containing information about a specific historical event, and the question might be about a detail of that event.
The question itself is the second input, and it should be well formed and specific. This ensures that cohere can effectively identify the relevant chunks of text needed to answer the question. A well-formed question clearly states what information is being sought and avoids ambiguity. For example, instead of asking "Tell me about World War II," a more specific question would be "What were the major battles of World War II?"
Outputs. The generated answer based on the relevant chunks identified by cohere and processed by a chain of language models (LLMs). The answer should be coherent and directly address the question posed. This output represents the final result of the method, providing the user with a concise and informative answer based on the text provided. For example, given the question "What were the major battles of World War II?" the output could be a list of the most significant battles, such as the Battle of Normandy, the Battle of Stalingrad, and the Battle of Midway. The relevant chunks that cohere identified is necessary for answering the question. This output provides transparency into the process, showing which sections of the text were deemed most relevant to the question. For example, if the question was "What were the major battles of World War II?" this output might contain the paragraphs from the text that describe the Battle of Normandy, the Battle of Stalingrad, and the Battle of Midway. Steps. The input question is first parsed using cohere's question answering capabilities. This step aims to understand the question's intent and identify key concepts and entities mentioned within the question. For example, if the question is "What were the major battles of World War II?" cohere would recognize major battles and World War II as key elements. The input text is then split into multiple chunks. This step divides the text into smaller, manageable units for cohere to analyze. Each chunk typically represents a paragraph or a set of related sentences, making it easier to identify relevant portions of the text. For example, A long historical document might be split into separate chunks for each chapter or section. Cohere then identifies the relevant chunks for answering the question, based on the past question and text chunks. This step uses Cohere's advanced language understanding capabilities to determine which chunks contain information relevant to the question. For example, Cohere might identify the chunks that mention battles in World War II, such as those describing the Battle of Normandy or the Battle of Stalingrad. Finally, a chain of language models (LLMs) is used to generate the answer to the question using the identified relevant chunks as input. This step combines the information from the relevant chunks and uses the LLMs to formulate a coherent and informative answer to the question. The LLMs can leverage their knowledge of language and context to generate a well-structured and comprehensive answer. Prerequisites. A Cohere application programming interface (API) key is necessary to use this method. You can obtain a Cohere API key by visiting the Cohere website and signing up for an account. This key acts as a credential for your application to access and utilize the Cohere service. Fine-tune parameters. The Cohere model to be used for question answering and chunk identification is a crucial parameter. Cohere offers various models, each with its strengths and weaknesses. Choosing the right model is essential for ensuring accurate and relevant results. For example, you might choose a model specifically designed for historical text if you are working with documents related to history. The number of chunks to split the text into is another critical parameter. The optimal number of chunks depends on the length and complexity of the text. A larger number of chunks might be needed for longer documents, while shorter documents might be adequately represented with fewer chunks. The number of relevant chunks to identify for answering the question determines how many chunks will be used as input for the LLMs. This parameter is closely tied to the complexity of the question. For example, a simpler question might only require a few relevant chunks, while a more complex question may necessitate the use of several chunks. Challenges and fixes. Challenge 1. The text might not be formatted in a way that is easy for Cohere to parse. Cohere might struggle to process text that lacks structure or is written in a highly informal style. For example, text with inconsistent capitalization or punctuation can create difficulties for Cohere's parsing process. Fixes to challenge 1. Formatting the text in a way that is easy for Cohere to parse is crucial. This involves ensuring the text has clear sentence boundaries, consistent capitalization, and appropriate punctuation. For example, dividing the text into paragraphs or bullet points can improve readability and parsing accuracy. Challenge 2. The question might not be well-formed or specific enough for Cohere to identify the relevant chunks. Ambiguous or vague questions can lead to Cohere selecting incorrect or irrelevant text chunks. For example, a question like "What happened in World War II?" is too broad and lacks focus, making it difficult for Cohere to pinpoint specific events or details. Fixes to challenge 2. Reformulating the question to be more specific and focused on the text provided is essential. This involves clearly stating what information is being sought and avoiding ambiguity. For example, instead of asking "Tell me about World War II," a more specific question would be "What were the major battles of World War II?" Challenge 3. The LLMs might not be able to generate a coherent answer using the identified chunks. Even with relevant chunks, the LLMs may struggle to combine the information effectively and produce a well-structured and comprehensive answer. For example, if the chunks are not organized logically or if the LLMs lack the necessary context, the answer might be fragmented or incoherent. Fixes to challenge 3. Experimenting with different LLMs and fine-tuning their parameters is crucial to improve the quality of the answer. This involves choosing models that are well suited for the specific task at hand and adjusting their settings to enhance their ability to understand and synthesize information from the provided chunks. Challenge 4. The identified chunks might not be relevant to the question. Cohere's chunk identification process may not always be perfect, and it could select chunks that are not directly related to the question. This might occur when the question is ambiguous or when the text contains complex or nuanced information. For example, Cohere might incorrectly identify a chunk discussing the causes of World War II when the question is about the major battles. Fixes to challenge 4. Adjusting the number of chunks identified by Cohere or trying a different model for chunk identification can help to address this challenge. For example, increasing the number of chunks might increase the likelihood of including relevant information. Experimenting with different Cohere models can also improve accuracy and ensure the selection of the most relevant chunks. Challenge 5. The identified chunks might not be sufficient to generate a complete answer. Sometimes, the relevant chunks identified by Cohere may not contain all the necessary information to provide a comprehensive answer. This might occur when the text lacks specific details or when the question requires a more nuanced understanding of the information presented. For example, a question about the outcomes of World War II might require additional context beyond the descriptions of the major battles. Fixes to challenge 5. Using a larger number of chunks or considering using additional context from the original text can help to address this challenge. By increasing the number of chunks, the LLMs might have access to more information relevant to the question. Additionally, incorporating additional context from the original text, such as background information or related sections, can provide the LLMs with a richer understanding of the topic and improve the completeness of the answer. Langchain Cohere React Multi-Hop Parsing Parse Citations. A multi-hop question answering system that combines langchain, Cohere, and React JS for retrieval and reasoning over scientific publications, extracting relevant information and generating citations for the answer. Inputs: a natural language question that is related to scientific publications. For example, what are the key findings of research on the effectiveness of personalized learning in improving student outcomes? A list of scientific papers in PDF or text format. These could be research articles, conference papers, or other scholarly publications relevant to the question being asked. Outputs: the answer to the question, formulated in a clear and concise way. A list of citations from the papers used to answer the question, formatted in a standardized citation style, e.g. Upper MLA. Steps: 1. Pre-process the question and the documents using langchain. This involves cleaning the text, splitting it into sentences, and potentially extracting key phrases to improve the effectiveness of subsequent steps. 2. Use Cohere's embedding model to generate vector representations of the question and documents. Cohere's embedding model is a powerful tool for representing text as numerical vectors. Each vector captures the meaning of the text in a way that allows for efficient comparison and similarity measurement. 3. Use langchain to find the most relevant documents based on the embeddings. By comparing the embeddings of the question and documents, langchain can identify the documents that are most likely to contain the answer. 4. Use Cohere's language model to reason over the selected documents, extracting relevant information. Cohere's language model has been trained on a massive corpus of text and is capable of understanding complex relationships between concepts and ideas. It can use the information from the selected documents to generate a comprehensive and informative answer to the question. 5. Generate a response to the question. Citing the relevant documents. The system uses the information extracted from the documents and the question to construct the coherent and informative answer. It then includes relevant citations to ensure the answer is properly attributed. 6. Render the answer and citations in a user-friendly React.js interface. The final step is to present the answer and citations in a visually appealing and easily digestible format. React.js is a popular JavaScript library for building user interfaces, allowing the system to create a dynamic and interactive experience for the user. Prerequisites. Install Python libraries langchain, cohere, and other required libraries. Langchain is a powerful framework for building applications that involve interacting with large language models and data sources. Cohere provides a suite of natural language processing APIs and models. Install Node.js and React.js. Node.js is a JavaScript runtime environment used for server-side development. React.js is a popular JavaScript library for building user interfaces. Fine-tune parameters. Cohere application programming interface key for accessing the embedding and language models. The Cohere API key is a security credential that allows the system to access and utilize the Cohere services. LangChain configuration parameters for document preprocessing and retrieval. These parameters include settings for document splitting, indexing, and similarity calculation. Challenges and fixes. Challenge 1: ensuring the accuracy and relevance of document retrieval. This is a key challenge in any question answering system that relies on retrieving information from a large corpus of documents. Fixes to challenge 1. Experiment with different embedding models and document retrieval algorithms. Using different embedding models can help capture different aspects of the meaning of the text, potentially leading to more accurate retrieval results. Similarly, experimenting with different retrieval algorithms can improve the effectiveness of the retrieval process. Fine-tune the retrieval parameters based on the specific dataset. Adjusting the parameters used for document similarity calculation can significantly affect retrieval accuracy. Fine-tuning these parameters based on the specific dataset can ensure that the retrieval process is optimized for the specific domain and content being used. Challenge 2: handling complex multi-hop reasoning tasks. Some questions require multiple steps of reasoning to arrive at the answer. For example, the question "What are the key findings of research on the effectiveness of personalized learning in improving student outcomes?" might require the system to first identify relevant research on personalized learning, then extract the key findings of that research. Fixes to challenge 2. Use a more powerful language model from Cohere. Using a more powerful language model with advanced reasoning capabilities can help the system handle more complex reasoning tasks. Explore different reasoning strategies and techniques. Investigating and implementing different reasoning techniques can improve the system's ability to handle complex reasoning tasks. This might involve techniques like knowledge graph reasoning, question answering over knowledge bases, or other approaches to handle multi-hop reasoning. LangChain Cohere React multi-hop parsing parse answer with prefixes summary. This component combines two powerful tools, LangChain and Cohere, to enable multi-hop question answering. LangChain provides the capability to extract relevant context from a large corpus of text. while Cohere leverages its advanced language model to generate comprehensive and accurate answers based on the extracted context. This synergistic approach empowers the system to address complex questions that require multiple steps of reasoning and information retrieval. Inputs: a natural language question that seeks to retrieve information from a given context. For example, what is the capital of France? A large body of text or a document containing relevant information to answer the question. This can be a Wikipedia article, a news article, or any other textual source. Outputs: an answer to the input question that is generated using the extracted context and the Cohere language model. The answer aims to be concise, informative, and consistent with the information provided in the context. Steps: langchain, a powerful library for building applications that use language models, is used to extract relevant context from the provided text. This involves identifying the most relevant passages or sentences that contain the information needed to answer the question. The extracted context is then passed to Cohere, a large language model developed by cohere.ai. Cohere analyzes the context and uses its deep understanding of language to generate a comprehensive answer that directly addresses the input question. Prerequisites: to use the Cohere API, you need to obtain an Application Programming Interface Key API key. This key acts as a credential that allows your application to authenticate with the Cohere service and access its powerful language models. Langchain is a Python library that simplifies the process of building applications that use language models. To utilize the capabilities of langchain, you need to install it on your system using package managers like pip. Fine-tune parameters. The Cohere model refers to the specific language model used for generating answers. You can choose from different models offered by Cohere, each trained on different datasets and optimized for different tasks. Selecting the appropriate model can significantly impact the quality and relevance of the generated answers. The langchain retriever is a component that determines how relevant information is extracted from the input context. You can choose from various retrieval techniques offered by langchain, such as keyword-based search, vector-based similarity search, or more sophisticated techniques. The chosen retriever influences the efficiency and accuracy of the context extraction process. Challenges and fixes. The provided context might be too lengthy for Cohere to process effectively. Langchain can be used to split the context into smaller chunks, enabling Cohere to focus on more manageable sections and produce higher quality answers. The generated answer might not align with the information provided in the context. This could be due to inaccuracies or biases in the context itself, or limitations of the Cohere model. To mitigate this, Cohere can be fine-tuned on specific datasets that are relevant to the domain of your application. This helps the model learn the nuances of the language and information specific to your use case, leading to more consistent and accurate answers. Summary of langchain Cohere React multi-hop parsing parse citations. This document describes a langchain-based application that integrates with the Cohere application programming interface to perform a multi-hop parsing task on textual inputs that contain citations. This application aims to extract citations from text and then leverage Cohere to generate concise summaries based on these extracted citations in response to user-defined queries. Inputs. The input text should contain embedded citations, such as those found in academic research papers, news articles, or blog posts. For example, the use of large language models in natural language processing is increasing. Brown et al. 2020. This trend is expected to continue as research in this area advances. The user provides a query or prompt that specifies the information they want to be included in the summary. For instance, a prompt could be, "What are the key findings of Brown et al. Regarding large language models in natural language processing?" Outputs. The application generates a summary of the input text, focusing on the information relevant to the user's query. This summary will incorporate insights gleaned from the extracted citations. The application outputs a list of all citations identified in the input text. This list provides a record of the sources referenced in the original text. Steps. The first step involves parsing the input text to extract citations. This parsing process identifies and extracts citation information, such as author names, publication year, and other relevant details. For example, the parser would identify Brown et al. 2020 as a citation and extract Brown et al. and 2020 as the author and year, respectively. The extracted citations are then passed to the Cohere application programming interface. Cohere is a service that provides natural language processing capabilities, including summarization. The user's query is also provided to Cohere. Cohere then uses these inputs to generate a concise summary of the text, focusing on the relevant information based on the query in the extracted citations. Prerequisites. The application requires a Cohere application programming interface key for accessing the Cohere API. To utilize this application, users need to register with Cohere and obtain an API key from their account. This API key acts as a credential, allowing the application to interact with the Cohere API. To integrate with the Cohere API, users need to install the Cohere package using a package manager like pip. This installation process makes the Cohere library available for use within the application, enabling the necessary communication with the Cohere API. The langchain library is a powerful tool for building applications that involve natural language processing tasks, especially those involving chains of interconnected components. This library provides a framework for building workflows involving tasks like text processing, knowledge retrieval, and language generation. Users need to install the langchain package to leverage its functionality within the application. Similar to the Cohere package installation, this step makes the langchain library available for use. Fine-tune parameters. The Cohere model parameter allows users to specify which Cohere model they want to use for summary generation. Cohere offers a variety of models, each with different strengths and capabilities. Users can choose the model that best suits their specific needs and the nature of the input text. The number of citations to extract parameter determines how many citations the application will attempt to extract from the input text. Users can adjust this parameter based on their requirements and the expected number of citations in the input text. For example, if the input text is a short blog post, extracting a limited number of citations might be sufficient. Conversely, a longer research paper may require extracting a larger number of citations to capture the full scope of the references. Challenges and fixes. One challenge in parsing citations is that they can be presented in various formats, making them difficult to extract automatically. For example, a citation might be in the form of Brown et al. 2020 or Brown et al. 2020. To overcome this challenge, the application can employ a more robust citation parser. These parsers are specifically designed to handle a wide range of citation formats, improving the accuracy of citation extraction. Another challenge lies in generating summaries that are relevant and informative based on both the user's query and the extracted citations. A generated summary might not accurately reflect the information contained in the citations or might deviate from the specific focus of the user's query. To address this challenge, users can fine-tune the cohere model with domain-specific data. This fine-tuning process involves providing the model with additional training data that is relevant to the specific domain of the input text. For example, if the input text is a research paper on machine learning, fine-tuning the model with a dataset of machine learning research papers can enhance its ability to generate summaries that accurately reflect the information in the citations and align with the user's query. Langchain cohere React multi-hop prompt convert to documents. Description of the inputs. User query, which is the text input from the user to be processed by the system. Context documents, which is the set of documents that provide context for the user query. Description of the outputs. Generated response, which is the text output generated by the system in response to the user query. And context documents. Description of the steps. Convert user query to cohere prompt, which is the process of converting the user query into a prompt that is understandable by the cohere application programming interface. Use cohere API to generate response, which is the process of using the cohere application programming interface to generate a response based on the converted prompt and context documents. Convert cohere response to langchain document, which is the process of converting the response generated by the cohere application programming interface into a document that is understandable by the langchain library. Description of the prerequisites. Cohere API key, which is the authentication key required to access the cohere application programming interface. Obtain API key from cohere, which is the process of getting the API key from the cohere platform by creating an account and generating a key. Langchain library, which is the Python library that is used to work with large language models. Install langchain library, which is the process of installing the langchain library on your system using the pip package manager. Description of the fine-tune parameters. Cohere model name, which is the name of the cohere model that will be used to generate the response. Cohere temperature, which is a parameter that controls the creativity of the response generated by the cohere model. Higher temperature values result in more creative and unpredictable responses, while lower temperature values result in more predictable and consistent responses. Description of the challenges and fixes. Cohere API error, which is an error that occurs when there is a problem connecting to or using the cohere application programming interface. Check API key validity, which is the process of verifying that the provided API key is valid and has not expired. Ensure correct API key, which is the process of making sure that the correct API key is being used and that it is correctly formatted. Check network connectivity, which is the process of checking that the system has a stable internet connection. Verify internet connection, which is the process of making sure that the system is connected to the internet and can access external resources. Langchain document conversion error, which is an error that occurs when there is a problem converting the response generated by the cohere application programming interface into a document that is understandable by the langchain library. Check response format, which is the process of verifying that the response generated by the cohere application programming interface is in the correct format that is expected by the langchain library. Ensure correct response structure, which is the process of making sure that the response has the correct structure and contains all the necessary information. Check langchain library version, which is the process of checking that the version of the langchain library installed on the system is compatible with the current requirements. Upgrade if necessary, which is the process of upgrading the langchain library to the latest version. If necessary, Langchain Cohere React Multi-Hop Prompt Create Directly Answer Tool Summary. This document summarizes Langchain's Cohere React Multi-Hop Prompt Create Directly Answer tool. It explains the tool's purpose, inputs, outputs, steps involved, prerequisites, fine-tune parameters, and potential challenges along with their solutions. Inputs: the question that needs to be answered using the provided text. This input is expected to be a natural language question, like what is the capital of France? The text that contains the information required to answer the input question. This could be a document, article, or any text format containing relevant information to the question. For example, a history book containing the capital of France, or a news article mentioning the recent capital change. Outputs: the answer to the question based on the provided text. This output is expected to be a concise and accurate answer to the input question, derived from the provided text. For example, for the question what is the capital of France? The output could be the capital of France is Paris. Steps: the question is broken down into multiple smaller sub-questions. For example, if the question is what is the capital of France and what is it famous for? It could be broken down into sub-questions like what is the capital of France? And what is Paris famous for? This step is crucial to ensure the tool can effectively process and analyze the question. Relevant information is retrieved from the provided text for each sub-question. Using the previous example, the tool would search the provided text for information about Paris and then search for information about what makes Paris famous. This retrieval process is done using various techniques, including keyword matching and semantic analysis. The retrieved information is combined to provide a comprehensive answer to the original question. Using the previous example, the tool would combine the information about Paris being the capital of France and its famous landmarks like the Eiffel Tower to provide a comprehensive answer to the original question what is the capital of France and what is it famous for? Prerequisites: Cohere Application Programming Interface Key API Key. This is a unique identifier required to access and use Cohere's Application Programming Interface API. The API provides access to Cohere's large language models, which are essential for generating natural language answers. For example, one can create an account on Cohere's website to obtain a valid API key. Langchain library. Installed Langchain is a Python library that facilitates building and using powerful language AI applications. It provides tools and frameworks for tasks like creating and using tools like the Cohere React Multi-Hop Prompt Create Directly Answer tool. Installing Langchain allows you to access its functionalities and integrate this tool into your application. Installing the library using pip command like pip install langchain would provide the access to use this tool. Fine-tune parameters. Number of hops. This parameter determines the number of sub-questions the tool will break a original question into. It controls the level of detail and complexity of the analysis. For example, a value of 2 would result in the tool breaking the question into 2 sub-questions. Increasing the number of hops increases the complexity of the analysis, potentially leading to more comprehensive and accurate answers. Cohere model. This parameter allows you to specify the specific Cohere language model to use for generating answers. Cohere offers various models with different capabilities and strengths. Selecting the appropriate model depends on the specific needs of your application. For example, you can choose a model that excels in factual accuracy for a question answering task. Challenges and fixes. Cohere Application Programming Interface API errors. These errors can occur if the provided API key is invalid or if there are network issues connecting to cohere's API. You can troubleshoot these errors by verifying the API key and checking your internet connectivity. Difficulty in breaking down questions. This is a common challenge when dealing with complex and multifaceted questions. Experimenting with different question breaking techniques, such as semantic analysis and keyword extraction, can help to improve the effectiveness of the tool. For example, using techniques like identifying keywords in the original question and breaking it down based on these keywords can improve the breakdown process. Langchain Cohere React Multi-Hop Prompt Create Directly Answer Tool. This YAML represents a tool that enables complex question answering using Cohere and langchain. It involves generating multi-hop prompts, sending them to Cohere for processing, and extracting the final answer. This tool, named Langchain Cohere React Multi-Hop Prompt Create Directly Answer Tool, utilizes Langchain to create multi-hop prompts for Cohere. The tool facilitates question answering by guiding the Cohere model through multiple reasoning steps, enabling it to understand complex relationships and provide accurate answers. Inputs: the user's question which needs to be answered, the text or document containing the answer to the user's question. Outputs: the formatted prompt for Cohere which is tailored for multi-hop reasoning. The model's generated answer which is extracted from Cohere's response. Steps: this step involves pre-processing the user's question to ensure it is consistent and ready for processing. This step involves cleaning and formatting the question for better understanding. This step involves identifying key entities or keywords from the user's question to aid in breaking down the question into smaller reasoning steps. This helps the model focus on relevant information and make the reasoning process more efficient. This step involves constructing a series of prompts using langchain that guide Cohere through the reasoning process. These prompts are carefully designed to break down the question into smaller, more manageable steps, which the Cohere model can then reason about sequentially. The generated prompts are sent to the Cohere Application Programming Interface API for processing. The Cohere API is a cloud-based service that allows developers to access Cohere's powerful language model capabilities. This step involves retrieving the final answer from the Cohere response and formatting it for the user. This step ensures that the final answer is presented in a clear and concise manner. Prerequisites: langchain is a powerful framework for building and deploying language models. It provides tools for connecting different components of the language model pipeline, including prompt engineering, data processing, and model interaction. This step involves installing langchain using pip, a package installer for Python. This step ensures that you have the necessary libraries and dependencies to use langchain. To access Cohere's language model capabilities, you need a Cohere API key. This key acts as a credential that authenticates your requests to the Cohere API. Obtaining the key typically involves signing up for a Cohere account and configuring your development environment to use it. Fine-tune parameters. Cohere offers various language models that cater to different tasks and capabilities. Choosing the right Cohere model depends on your specific use case and the complexity of your questions. Prompt engineering is crucial for effective question answering. It involves carefully crafting prompts that guide the Cohere model towards the desired answer. Fine-tuning the prompts involves experimenting with different structures, wordings, and contextual cues to achieve optimal performance. Challenges and fixes. One of the challenges in complex question answering is limited context understanding. The model may struggle to grasp complex relationships between entities within the provided context, potentially leading to inaccurate answers. Fixes to challenge 1. Improving context formatting involves structuring the context in a way that is more organized and readable. This can be achieved by highlighting key entities, relationships, and relevant information, making it easier for the model to comprehend. Named entity recognition (NER) is a technique that identifies and labels important entities in text. By employing NER techniques, the tool can provide the cohere model with valuable insights into the entities present in the context, aiding its understanding of complex relationships. Another challenge in question answering is question ambiguity. The model may misinterpret ambiguous questions or fail to recognize the intended meaning, leading to inaccurate or irrelevant answers. Fixes to challenge 2. Clarifying question intent involves rephrasing or refining the question to ensure that the instructions are clear and unambiguous. This step aims to eliminate any potential misinterpretations by the model. Providing additional context can help guide the model's interpretation. This involves supplementing the original question with relevant background information, historical data, or other contextual details that help the model understand the question's nuances and complexities. This approach provides the model with a more complete understanding of the question and its context, enabling it to produce more accurate answers. Langchain cohere React multi-hop prompt render messages. Inputs: the query to be processed by the system, the context that the system can use to answer the query. Outputs: the answer that the system generates based on the query and context. Steps: the first step in the process is to generate text using the cohere API. The second step is to process the generated text using langchain to extract the final answer. Prerequisites: the cohere application programming interface key is required to access the cohere API. The cohere API key is a unique identifier that allows access to the cohere API. It is required to use the cohere API. The langchain library is required to process the generated text and extract the final answer. Langchain is a Python library that provides a framework for building and using language models. It allows you to chain together different language models and other tools to perform complex tasks. It is required for this process to work as it is responsible for processing the text generated by cohere and extracting the final answer from the generated text. Fine-tune parameters: the specific cohere model that will be used to generate text. The temperature parameter controls the creativity and predictability of the generated text. A higher temperature will result in more creative and unpredictable text, while a lower temperature will result in more predictable and consistent text. Challenges and fixes: if the system is unable to access the cohere API due to an invalid API key, then the API key should be checked. The cohere API key is required to access the cohere API. If the API key is invalid, then the system will be unable to access the cohere API. To fix this, the API key should be checked and corrected. If the system is unable to process the generated text due to an error with the langchain library, then the langchain installation should be checked. The langchain library is required to process the generated text. If the langchain installation is incorrect or corrupted, then the system will be unable to process the generated text. To fix this, the langchain installation should be checked and reinstalled if necessary. If the system generates an incorrect answer, then the parameters used to generate text should be adjusted. The parameters used to generate text can affect the quality of the generated text and the accuracy of the final answer. To fix this, the parameters should be adjusted and the process should be run again to see if the answer is more accurate. Langchain cohere React multi-hop prompt render observations. Inputs: the user's question or input, which the system will attempt to answer. For example, What is the capital of France? A step-by-step reasoning process that the system uses to arrive at the final answer. For example, the capital of France is Paris. Paris is a city in France. Therefore, the capital of France is Paris. Outputs: the final answer that the system provides to the user's question. For example, Paris. Steps: the process of identifying and extracting relevant information from the given context or knowledge base. For example, extracting information about the capital of France from a Wikipedia article. The process of generating a coherent and logical chain of thought based on the extracted information to arrive at the final answer. For example, reasoning that Paris is the capital of France based on the extracted information. The process of producing the final answer based on the chain of thought. For example, presenting Paris as the final answer. Prerequisites: an application programming interface key that grants access to the Cohere language model, which is used for text generation and understanding. A Python library that provides tools and building blocks for creating and deploying language models. A JavaScript library used for building user interfaces, which allows for the creation of interactive components for displaying the system's outputs and allowing user input. Fine-tune parameters: a parameter that controls the randomness and creativity of the system's output. A higher temperature value leads to more unexpected and diverse outputs, while a lower value leads to more predictable and consistent outputs. A parameter that controls the number of possible outputs the system considers before selecting pay. Final answer: a higher top K value allows the system to explore a wider range of possible answers, while a lower value limits the system to a smaller set of possible outputs. Challenges and fixes: the ability of the system to process and understand large amounts of text, especially when the context is long or complex. A technique that divides the context into smaller chunks, making it easier for the system to process and understand. For example, dividing a long Wikipedia article into several smaller sections. The system's tendency to produce inaccurate or misleading information, which can happen due to errors in the underlying data or biases in the training data. A technique that involves training the system on a dataset of correctly labeled examples, which helps to improve the system's accuracy and reduce biases. For example, training the system on a dataset of questions and answers, where the answers are verified to be accurate and unbiased. The potential for the system to exhibit biases or unfairness, which can be due to biases in the training data or in the system's design. Techniques that involve adding more diverse data to the training set, or adjusting the system's parameters to reduce biases. For example, adding data from underrepresented groups or adjusting the system's parameters to penalize biased outputs. Langchain Cohere React Multi-Hop Prompt Render Role Summary. This role is specifically designed for generating multi-hop question answering prompts for Cohere. Multi-hop question answering refers to answering questions that require reasoning over multiple pieces of information or multiple hops within a given context. Cohere is a powerful language model that can be used to generate creative text formats, translate languages, and answer questions. Inputs. Question: this is the question that the user wants to have answered. The question should be phrased in a way that is clear and concise, and it should be relevant to the context provided. Context: this is the body of text that the question is based on. The context should provide the information needed to answer the question. This might be a collection of documents, a news article, a Wikipedia page, or even a short story. Outputs. Multi-hop question answering prompt. The generated prompt is a set of instructions given to Cohere. designed to guide the model in formulating an answer to the question based on the provided context. Steps. Identify the question type. The first step is to analyze the question and determine the type of question being asked. This might involve recognizing if the question is a factual question, a definitional question, or a more complex reasoning question. Extract relevant information. The second step is to identify and extract the most relevant pieces of information from the context that are needed to answer the question. This might involve using techniques like keyword extraction, sentence similarity matching, or document summarization. Construct the prompt. The final step is to construct the prompt that will be sent to Cohere. This prompt will be formatted in a way that guides Cohere to use the extracted information to generate a meaningful and accurate answer to the question. Prerequisites. Cohere Application Programming Interface Key. The Cohere API key is a unique identifier that allows you to authenticate with the Cohere API. It's required to access the Cohere's powerful language model and its various features. You'll need to obtain a Cohere API key from the Cohere website to use this role. An example key might be your Cohere API key. Langchain library. Langchain is a Python library that helps streamline and simplify interactions with different large language models (LLMs) like Cohere. It's a foundational element for building and integrating Cohere into your applications. An example of a langchain library is langchain. Fine-tune parameters. Temperature controls the randomness of the language model's responses. A higher temperature value increases the randomness, while a lower value produces more deterministic responses. It's essentially a control knob for how creative and surprising the responses should be. Max tokens. Max tokens specifies the maximum number of tokens that the language model can generate in a response. Tokens are the basic units of text in natural language processing, and this parameter helps control the length of the generated output. Challenges and fixes. Unable to identify the correct question type. If the role fails to correctly identify the type of question, the resulting prompt may not be effective in guiding Cohere to answer the question correctly. This can be fixed by using a more sophisticated question classification model that can analyze the question and identify its type with greater accuracy. Inability to extract relevant information. If the role cannot extract the relevant information from the context, the generated prompt will not be able to provide Cohere with the necessary information to answer the question. This challenge can be addressed by using a better document retrieval or summarization model that can effectively identify and extract the most relevant information from the context. Prompt not well formatted. If the prompt is not well formatted, Cohere might struggle to understand the instructions and provide an accurate answer. The solution is to adjust the prompt structure and parameters, making sure they are clear, concise, and appropriate for the specific question and context. This involves adjusting elements like the prompt structure, the types of instructions provided, and the format of the expected output. Langchain Cohere React Multi-Hop Prompt Render Role Summary. The Cohere React Multi-Hop Prompt Render Role is used to summarize the Cohere React Multi-Hop Prompt, which is a component of the langchain framework. The goal is to provide a concise and understandable summary of the prompt's purpose and functionality. Inputs. The Cohere React Multi-Hop Prompt Render Role is an input that defines the role or purpose of a prompt. It is important to understand this role to effectively summarize the prompt's functionality and usage. Langchain components are the building blocks of the langchain framework, which is a framework for building and deploying language-based applications. This input includes the essential components that make up the Cohere React Multi-Hop prompt. such as the prompt template, the language model, and the chain. Outputs. The output of this process is a summarized text that provides a concise and understandable description of the Cohere React multi-hop prompt. This summary should highlight the prompt's main features, usage, and purpose. Steps. The first step in summarizing the Cohere React multi-hop prompt is to extract all the important information from the prompt itself. This involves identifying the key components, parameters, and functionality. The second step involves summarizing the extracted information in a way that is easy to understand and digest. This summary should provide a clear and concise overview of the prompt's role in capabilities. Prerequisites. A solid understanding of langchain is necessary to understand the Cohere React multi-hop prompt. Render role. Familiarity with langchain's core components, such as chains, prompt templates, and language models (LLMs), is crucial for understanding the context and functionality of the prompt. Understanding the concept of multi-hop question answering (MHQA) is important to comprehend the purpose of the Cohere React multi-hop prompt. MHQA refers to question answering techniques that involve retrieving information from multiple sources or steps. The prompt leverages this approach to answer complex questions that require multiple hops of information retrieval. Fine-tune parameters. The summarization model plays a crucial role in generating a concise and informative summary of the Cohere React multi-hop prompt. Fine-tuning this model to the specific task of summarizing prompts is essential for achieving accurate and relevant outputs. The maximum length parameter controls the length of the generated summary. This parameter is used to ensure that the summary remains concise and avoids unnecessary verbosity. For example, a maximum length of 100 words might be appropriate for a short summary. Challenges and fixes. Challenge 1. One of the challenges in summarizing the Cohere React multi-hop prompt is that the summarization model might not fully understand the context of the prompt. This can lead to inaccurate or incomplete summaries. Fixes to challenge 1. To address this challenge, more context can be provided to the model in the form of additional input data. This could include information about the prompt's purpose, functionality, and usage. For example, providing examples of how the prompt is used in practice can help the model better understand its context. Challenge 2. Another challenge is that the summarization model might not capture all the important information from the prompt. This can result in summaries that are incomplete or miss key details. Fixes to challenge 2. To tackle this challenge, the summarization model can be fine-tuned to specifically capture the information required for summarizing prompts. This involves training the model on a dataset of prompts and their corresponding summaries, allowing it to learn the patterns and relationships between the prompt and its summary. For instance, the model can be trained to recognize keywords, phrases, and components that are essential for summarizing a prompt. Langchain Cohere React Multi-Hop Prompt Render Tool Summary. This tool utilizes the Cohere Application Programming Interface (API) to perform multi-hop reasoning. By combining entity extraction from questions, relevant document retrieval, and answer generation inputs, this is the question that needs to be answered using the provided document. For example, what is the capital of France? This is the document that contains the information required to answer the question. For example, a Wikipedia article on France. Outputs. This is the answer generated by the tool in response to the question based on the provided document. For example, the capital of France is Paris. Steps. Extract key entities from the question. For example, Capital and France from the question "What is the capital of France?" Retrieve documents from the document collection that are relevant to the extracted entities. For example, retrieve the Wikipedia article on France. Combine the extracted entities in relevant documents to form a context for the answer generation. For example, combine the entities capital and France with the Wikipedia article on France. Generate the answer using the cohere API based on the combined context. For example, Paris is generated as the answer using cohere. Prerequisites. A valid cohere API key is required to access the cohere API for answer generation. The API key allows the tool to authenticate and utilize cohere's services. Install the langchain library. This library provides the necessary functionalities for interacting with the cohere API and performing other tasks like entity extraction and document retrieval. Fine-tune parameters. The cohere model can be fine-tuned to improve the quality of the generated answers. Different cohere models have varying strengths and weaknesses, and choosing the appropriate model can enhance the accuracy of the responses. The cohere temperature parameter controls the randomness of the generated responses. Adjusting the temperature can influence the creativity and diversity of the generated answers. Higher temperatures lead to more diverse and potentially unexpected answers, while lower temperatures produce more predictable and conservative responses. Challenges and fixes. If the tool struggles to retrieve relevant documents, consider adjusting cohere parameters, such as the temperature or the model used, to enhance the relevance of retrieved documents. Additionally, explore using a different embedding model, which maps text to numerical representations, to improve document similarity and retrieval. If the generated answer does not accurately address the question, try adjusting cohere parameters, such as the temperature or the model used, to optimize the answer generation process. Experiment with different prompt formats and phrasing to guide cohere towards generating more relevant and accurate responses. Langchain Cohere React Multi-Hop Prompt Render Tool args. Inputs. The question that the user wants to ask. For example, what is the capital of France? The context that the user provides to help answer the question. For example, France is a country in Western Europe. Its capital is Paris. Outputs. The answer to the question. For example, Paris. Steps. The tool identifies the relevant context from the provided context to answer the question. For example, France is a country in Western Europe. Its capital is Paris. The tool uses the identified context to generate an answer to the question. For example, Paris. Prerequisites. The Cohere application programming interface key is required to use the Cohere API. It is used to authenticate the user and allow them to access the API. The user must obtain a Cohere API key from the Cohere website. Fine-tune parameters. A parameter that allows the user to control the randomness of the response. A higher temperature value means more randomness and a lower value means less randomness. Challenges and fixes. The context provided may not be relevant to the question. For example, the context may be about the history of France and not its capital. The tool can retry with a different context or ask the user for more information. The answer generated may not be comprehensive. For example, the answer may only include the capital of France but not other relevant information. The tool can iterate with additional context to provide a more comprehensive answer. Langchain Cohere React Multi-Hop Prompt Render Tool Summary. This tool utilizes langchain to generate multi-hop prompts for Cohere. It combines information from multiple sources to answer complex questions. Inputs. The question that needs to be answered. For example, what is the capital of France? The initial context that provides information relevant to the question. This could be a document, a set of documents, or a knowledge base. For example, France is a country in Western Europe. Paris is a city in France. Outputs. A multi-hop prompt for Cohere. This prompt is designed to be used with Cohere's large language models to generate answers to complex questions. Steps. Extract relevant entities from the question. For example, France and capital from the question, what is the capital of France? Generate a list of potential answer sources that contain information relevant to the extracted entities. For example, a list of documents containing information about France and its capital city. Construct the multi-hop prompt for Cohere by combining the extracted entities, the potential answer sources, and the question. This prompt guides the Cohere model to retrieve information from the sources and generate a comprehensive answer. Prerequisites. Langchain needs to be installed. You can install langchain using the following command. pip install langchain. A Cohere application programming interface API key is required. This key is used to access Cohere's services. Cohere API key. Fine-tune parameters. The number of hops in the multi-hop prompt. This refers to the number of sources the prompt should consult to generate the final answer. A higher number of hops allows for more complex question answering but may increase latency. For example, a 2-hop prompt might first retrieve relevant documents and then use those documents to find the final answer. The entity extraction model used to extract entities from the question. This model determines the accuracy of entity extraction, which in turn affects the quality of the final answer. Challenges and fixes. Entity extraction failure. Where the entity extraction model fails to identify relevant entities from the question. For example, if the entity extraction model fails to identify France from the question, what is the capital of France? The prompt may not be able to generate an accurate answer. Use a more robust entity extraction model, such as a model trained on a larger dataset of entity extraction tasks. Answer source generation failure. Where the tool fails to generate a list of relevant answer sources. For example, if the tool fails to identify documents containing information about France and its capital, the prompt will be unable to generate an accurate answer. Provide more context to the answer source generation logic or refine the logic itself to improve its ability to identify relevant sources. This could involve incorporating additional knowledge about the entities or using more advanced techniques for source retrieval. Langchain Cohere React Multi-Hop Prompt Render Tool Signature Summary. This tool signature describes how to utilize Cohere, a language AI platform, in conjunction with langchain, a library for building and deploying language models, to implement a multi-hop question answering system within a React application. Multi-hop question answering refers to the ability to answer questions that require reasoning across multiple pieces of information. Inputs. This represents the user's inquiry or question that the system aims to answer. For instance, a user might ask what are the benefits of using langchain with Cohere for multi-hop question answering. This input denotes a collection of documents or text resources that the system will use to find the answer to the user's question. These documents can be articles, web pages, books, or any other type of text data relevant to the topic of the question. Outputs. The output of this tool signature is the answer to the user's question based on the provided documents. It aims to be a comprehensive and accurate response that addresses the multi-hop aspects of a question. meaning that it draws information from multiple sources within the documents to formulate the answer. Steps. The initial step involves using langchain to break down the user's question into multiple smaller, more manageable sub-questions. This step is essential for multi-hop question answering as it helps to identify the individual pieces of information needed to answer the overarching question. This step leverages Cohere's powerful language models to generate embeddings for each of the sub-questions and the documents provided. An embedding is a numerical representation of a piece of text, allowing the system to measure the semantic similarity between different pieces of text. By generating embeddings, the system can effectively understand the meaning of the questions and documents. Using the embeddings generated in the previous step, langchain is utilized to find the most relevant documents for each of the sub-questions. This involves comparing the embeddings of the sub-questions with the embeddings of the documents to determine which documents are most closely related to the sub-questions. Cohere is then employed to generate an answer for each sub-question based on the relevant documents identified in the previous step. This step utilizes Cohere's ability to understand and generate coherent text to produce concise and informative answers for each sub-question. Finally, the answers to all the sub-questions are combined to generate a final answer to the original user question. This step involves integrating the individual answers to form a comprehensive and coherent response that addresses the original query. Prerequisites. The system requires the installation of two crucial libraries, langchain and cohere. These libraries provide the core functionalities needed to implement the multi-hop question answering process. Installing these libraries can be done via the npm package manager by running the command npm install langchain cohere. To utilize Cohere's APIs, an application programming interface API key is required. This key serves as a unique identifier for accessing Cohere's services and can be obtained by registering for a Cohere account. Fine-tune parameters. This refers to the specific Cohere model used to generate answers for the sub-questions. The choice of model can significantly impact the quality of the answers generated. And selecting a model that is appropriate for the domain of the documents is essential. This parameter defines the specific Cohere embedding model used to represent the text in numerical form. The selection of the embedding model influences the accuracy of the similarity search performed by langchain to identify relevant documents. This parameter specifies the type of langchain chain used to orchestrate the multi-hop question answering process. Choosing the appropriate langchain chain allows for the optimal execution of the different steps involved in the process. Challenges and fixes. Handling complex questions, especially those requiring reasoning across multiple pieces of information, can be challenging. Langchain can be used to break down the question into simpler sub-questions, effectively addressing the complexity by dividing the problem into smaller, manageable parts. Finding the most relevant documents for each sub-question is crucial for accurate answers. Cohere's embedding models, combined with langchain's similarity search capabilities, allow for efficient retrieval of relevant documents, ensuring that the system bases its answers on appropriate information. Generating accurate and informative answers requires careful consideration of the specific domain of the documents. Fine-tuning the Cohere model and embeddings for the specific domain can significantly improve the accuracy and relevance of the answers generated. Multi-hop question answering often involves chaining together multiple Cohere calls to answer the question effectively. Langchain provides the necessary infrastructure to chain these calls together. ensuring that the system can handle the complexity of multi-hop queries by systematically drawing information from multiple sources. Langchain cohere rerank method for enhancing search results is a YAML structure that describes the process of using coheres reranking API for improving the order of search results, which is a key aspect of enhancing search results quality. Use coheres reranking application programming interface to improve the order of search results. This involves reordering the results based on their relevance to the user's search query. Inputs: a list of search results, often retrieved from a search engine or a knowledge base, that are generated by a search engine or other information retrieval system. These results can be documents, articles, web pages, or other relevant content. A user-entered query that initiated the search process, representing the user's intent and information need. Outputs: a list of re-ranked search results, where the results are presented in an order that reflects their relevance to the query, as determined by coheres re-ranking API. The higher ranked results are expected to be more closely aligned with the user's intent and information needs. Steps: use langchain to retrieve search results. Langchain is a library that provides tools for working with language models and other AI tools. In this context, it would be used to fetch initial search results based on the user's query. Send the search results and query to coheres reranking application programming interface. The reranking API, provided by Cohere, is designed to analyze the search results in the user's query and determine the most relevant order. For the results, receive the re-ranked search results from Cohere. Cohere's re-ranking API returns the reordered search results, prioritizing those considered most relevant to the query. Prerequisites: Cohere Application Programming Interface Key is a unique identifier that grants access to Cohere's services. It's necessary to authenticate and authorize requests to the Cohere API. A Cohere API key needs to be obtained and set up to access Cohere's services, including the reranking API. LangChain library is a framework that simplifies the integration of language models into applications. It provides a convenient way to work with search results, process data, and interact with Cohere's reranking API. The LangChain library is required to work with search results, interact with Cohere's API, and manage the overall workflow of reranking. Fine-tune parameters. Cohere model to use is a specific language model offered by Cohere that's trained for reranking tasks. Different models may have varying levels of accuracy and performance. Choosing the right Cohere model is crucial for optimal reranking performance. Factors to consider include the complexity of the search results, the nature of the query, and the desired level of accuracy. Number of results to rerank is the quantity of search results that will be reordered using Cohere's API. This parameter determines how many search results are included in the reranking process. A higher number of results allows for more comprehensive ranking, but can also increase processing time. Challenges and fixes. API request errors are issues that may arise when communicating with Cohere's API, such as network connectivity problems, authentication failures, or invalid API requests. Troubleshooting API request errors might involve checking network connectivity, verifying API key validity, and reviewing the format and structure of API requests. Incorrect model selection involves using a Cohere model that's not suitable for the specific reranking task. The chosen model may not be adequately trained or optimized for the type of search results or query being processed. Choosing the appropriate Cohere model is critical. It's important to consider the characteristics of the search results in the query to select a model that's well suited for reranking those specific data types. Langchain Cohere React Multi-Hop Prompt Render Type Summary. Inputs. Text description: a textual input representing the content of the document you want to query. This can be an article, blog post, website, or any other text-based source of information. Questions description: a set of natural language questions that you want to ask about the text input. These questions can be open-ended or specific, as long as they relate to the information contained within the text input. Outputs. Answers description: the generated answers to the questions provided. These answers are derived from the provided text and should be accurate and relevant to the questions asked. Steps. Retrieve context description: the step retrieves relevant information from the input text that helps in answering the given questions. Answer questions description: the step utilizes the information retrieved from the input text to provide answers to the questions. Leveraging the Cohere language model. Prerequisites. Cohere API key description: the Cohere application programming interface key, which provides access to the Cohere language model. This key is required to utilize the Cohere API for generating answers to questions. Fine-tune parameters. Model type description: the type of Cohere language model to use for answering the questions. Choosing the appropriate model type is important for obtaining accurate and relevant answers. Temperature description: the temperature parameter controls the randomness of the responses. Higher temperature values encourage more creative and diverse answers, while lower values lead to more focused and predictable responses. Challenges and fixes. Incorrect context description: if the retrieved context is not relevant to the given question, you can rerun the retrieval process to ensure that a more accurate and suitable context is retrieved. Unclear question description: when the question is unclear or ambiguous, it can be helpful to rephrase the question to clarify its meaning. This ensures that the language model is able to accurately understand and respond to the question.